Hi everyone, and welcome to my course Azure Traffic Manager. This is my third course in Azure Load Balancing Services. Previously, I have done separate courses for Azure Application Gateway and Azure Front Door. And this course is going to do a deep dive in Azure Traffic Manager. And I have a plan to cover Azure Load Balancer in near future as well. So I will be covering all 4 Azure Load Balancing Services. This is my target. Now, first thing is first. This course is 100% hands-on, which means there is no PowerPoint presentations at all. All I'm going to be presenting is Azure Portal, Microsoft documentation, and whiteboard. Because I'm a big fan of the pragmatic approach, I want to give you the opportunity to learn something new, practically, not just theoretically through PowerPoint slides. In this course, we are going to talk about different routing methods that are supported in Traffic Manager Profile, like Priority routing method and how we can use it in disaster recovery situation, Weighted routing method and how we can use it to implement blue-green deployments, Performance routing method, and we will see how can we use it to provide lowest latency to the end user, Geographic routing methods, and how we can use it to send the traffic to different endpoints based on the user location. And then we have subnet routing and multi-value routing. Then we will go one step deeper and talk a little bit about Traffic Manager configurations, like how we can create an Alias Record for our Traffic Manager profile, and what are the different types of the endpoints supported in Traffic Manager, and how can we monitor these endpoints to know the health status, so the Traffic Manager knows whether to send the traffic to these endpoints or not. Then we will see the real user measurements and get traffic view in our Traffic Manager profile. Then we will move to the advanced section, where we are going to see how can we use nested profiles in Traffic Manager. So we will be able to combine different Traffic Manager profiles in one architecture, like for example having one performance routing method sending traffic to geographic routing method to achieve a certain targets in your architecture. Then we will talk about how we can combine different load balancing services in one architecture. As I mentioned before, Azure Load Balancing Services has 4 services. And in a complex architecture, you will find yourself need to combine multiple load balancing services in one architecture. So we are going to see how can we combine these different load balancing services in one architecture and make them work in harmony. Then we are going to talk about the disaster recovery and blue-green deployments using Traffic Manager. Finally, we will get to the monitoring and how we can set up diagnostic settings on our Traffic Manager. We will understand the key metrics and how we set up some alerts on them. And finally, we are going to talk about the log analytics workspace as well. So this is just a quick introductory video to let you know what you should be expecting when you watch this course. This is enough for an introduction for this course. Now let's get started and let's dive deep into Azure Traffic Manager. I'll see you in the next video. Thanks for watching. Hi everyone. In this video, I'm going to give you a quick introduction about Azure Traffic Manager. In case if you don't know, Azure has 4 load balancing services: Traffic Manager, Load Balancer, Front Door, and Application Gateway. And I've already done detailed videos on the Application Gateway and Front Door, and I'm going to put some links for you if you are interested to watch them. Now let's get back to Traffic Manager. Traffic Manager is a DNS traffic load balancer, which allows you to distribute the traffic coming to your application that's hosted in multiple Azure regions. And of course, by having your application hosted in multiple Azure regions, it's going to improve the availability of your application and reduce the latency to your end users. Traffic Manager has different routing methods. And when using the right routing method, you will be able to direct the traffic to the healthy endpoints of your architecture. And in order for Traffic Manager to know the health status of different endpoints in your architecture, Traffic Manager has health monitoring capabilities that will allow Traffic Manager to know the health status of your endpoints, whether they are inside Azure or outside of Azure. So by using the traffic routing method with the endpoint monitoring, you can build failover models for your architecture. Traffic Manager is resilient to failure, including a failure to an entire Azure region. Now let's talk about the key features of using Traffic Manager. First of all, it's going to increase the application availability. Given that your application is going to be deployed in multiple Azure regions, and then you are going to use Traffic Manager to distribute traffic across multiple regions, then if one region went completely offline, then Traffic Manager will be able to direct the traffic to the healthy Azure region that has your resources deployed on it. So by using Traffic Manager in a multi-region deployment, it will definitely increase the availability of your application. And in addition to the application availability, Traffic Manager can improve the application performance as well. Since the Traffic Manager has a certain routing methods that will be able to direct the incoming user request to the closer Azure region to the user location. And by doing this, it's going to decrease the latency of the request, and of course, it's going to improve the availability or the performance of your application. Also, you can use Traffic Manager to do service maintenance without downtime, assuming that you are using Traffic Manager and your application is hosted or deployed in multiple Azure regions. You may want to decide to take one of the regions completely offline to do some upgrades or maintenance tasks or whatever you want to do. At the same time, you are going to ask Traffic Manager to direct the traffic to the other healthy regions. Until you finish the upgrade or the maintenance of the region, then you can ask Traffic Manager to direct the traffic to that region again. So by doing that, Traffic Manager will help you to do maintenance without any offline time for the end user or without any downtime. In addition to that, you can combine hybrid applications. You can use Traffic Manager for cloud migration purposes, since the Traffic Manager is able to direct the traffic to Azure resources and non-Azure resources, as long as they are accessible through the public internet. It's very common to use Traffic Manager in cloud migration scenarios. And in case you have complex deployment in your architecture, you have an option to use nested Traffic Manager profiles to allow you to use different routing methods in your Traffic Manager to support the complex deployment or complex architecture. This was a quick overview of Azure Traffic Manager, and we are going to dive into more details in all of these areas later in this video. As I mentioned already, there are 4 Azure load balancing services. I'm sure that some of you might be confused what would be the right service to use in a certain situation. And in order to help you to make this decision, I'm going to refer you to this table here, which allows you to choose the right Azure service for your scenario. The table primarily has 2 dimensions, traffic and regional. And the first question you want to ask yourself, whether your scenario needs HTTP traffic or non-HTTP traffic. In case of your situation requires HTTP traffic, then in this case you will have 2 options, Azure Front Door and Azure Application Gateway. Then the second dimension now becomes really useful to tell you the coverage of your architecture, whether you want to have a global coverage or regional coverage. In case you have HTTP traffic requirements requires a global coverage, then Azure Front Door will be the only service that will allow you to do this. However, if you have HTTP requirements with a regional coverage, then you can use Application Gateway. Having said that, you can combine using Azure Front Door with the Application Gateway if your architecture requires that. So you might have Azure Front Door to distribute traffic globally to different Azure regions. And then in each of these Azure regions, you might have Application Gateway to distribute traffic to different endpoints within the same region. However, if you have a non-HTTP traffic requirements, you have 2 options, whether to use Traffic Manager or use Azure Load Balancer. And again, the second dimension is going to help you now to determine what would be the right service for you. If you have a global coverage requirement, then Traffic Manager will be the right service for you. However, if you have a regional coverage only, then you can use Azure Load Balancer. This table is going to help you a lot to determine what's the right Azure Load Balancing service that you should use in different situations, based on two dimensions, traffic and coverage, regional coverage. The other thing I want you to be aware of is the decision tree for load balancing in Azure. So it's simply a few questions, and based on your answers, Azure is going to recommend you different load balancing services that works best for your requirement. And the key question we have in here is the type of your web application, whether it requires HTTP or HTTPS traffic. Let's go for the easy path first. If you don't have this requirement, then you could be using Azure Load Balancer or Traffic Manager plus Load Balancer. However, if your application requires HTTP or HTTPS traffic, then you could use different services between Application Gateway, Front Door, or combination of both, or sometimes you can use Application Gateway Ingress Controller if you are using AKS cluster, and in some situations if you are using VM, you can use Azure Front Door plus Load Balancer. So the decision tree is going to be helpful for you to determine what would be the right service for you to use. And I would suggest to keep it in line with the table we talked about before, so to help you to make this decision about what's the right Azure Load Balancing service for you to use in different situations. This is not everything I want to show you in this area. If you go to the Azure portal and if you type Load Balancing, you will see an option here helping me choose. So it's simply all of the questions we have seen before in the decision tree. It's gonna ask you here, and based on your answers, Azure is going to recommend or narrow down different load balancing services to the service that you should be using based on the answers you have provided in these questions. That's all I have for you in this video. It was a quick one to make you familiar with the Azure Traffic Manager and to understand the different Azure load balancing services in Azure and what are the differences between them. And we have looked at the comparison or the different dimensions that are going to help you to decide what would be the right service to use in different situations. We have seen the decision tree for load balancing services, and we have seen the Azure portal, how it can help you to make this decision. In the next video, we are going to start creating a traffic manager profile, and we'll see how can we use it to direct traffic using different routing methods. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to go ahead and create our traffic manager profile. And we are going to see how can you use your traffic manager to deliver high availability for your web application. And I'm going to open the whiteboard to show you exactly what we are going to build on Azure portal. Firstly, we are going to use Sydney region as our primary region. And I'm going to use US region as my failover region. And in Sydney region, I'm going to create app service plan. And let's call it Sydney app service plan. And then I'm going to create an app service, and let's call it Sydney app service. And I'm going to host the same services in US region as well. I'm going to create app service plan. I'm going to call it US app service plan. Then I'm going to create app service. Then I'm going to call it US app service. Then I'm going to create traffic manager profile, and let's call it app service traffic manager or whatever you want to call it. Then I'm going to configure traffic manager to send the traffic primarily to Sydney region, to Sydney app service to be specific. Then in case of any failure happens to Sydney app service, I'm going to configure the traffic manager to send the traffic to US app service as a failover plan. So this is what we are going to build in Azure portal. So let's get back to Azure portal and go ahead and create these services. Then let's go to the app services and let's go ahead and create a new app service. Let's go ahead and create a new resource group. Let's call it RG Sydney, for example. And then let's put a name for our website in Sydney. I'm gonna call it Sydney App Service. Hopefully this is going to be available. Then I'm going to use code, the latest version available in .NET Core, .NET 6, and I'm going to host it in Australia East region, in Sydney region. And as you can see here, I don't have app service plan at the moment. So let's go ahead and create a new app service plan in Sydney region. And let's go ahead to the next step. In the deployment, let's keep it to the default settings. Go into the networking. Again, leave it to the default settings. For the monitoring, I'm going to disable the application insights monitoring because I don't need it for this exercise. Then going all the way down and create my app service. This is going to create app service and app service plan in Sydney region. And until my app service is being created, let's go ahead and create the app service plan in US region. Let's go ahead and create a new one. Again, let's create a new resource group. Let's call it RGUS. And let's specify a name for our US app service. Let's call it US app service test. All right, I'm going to use the same settings as well. Code, .NET 6, hosted in Central or East US. And again, I'm going to create a new app service plan because I don't have app service plan in US region. And let's go to the next step. Leave it to the default settings. And same for the networking. And for the monitoring, I'm going to disable application insights monitoring because again, it's not required for this exercise. And let's go ahead and create my app service in US region. And while I am waiting for the app service in US region to be created for me, I'm going to go ahead and create a traffic manager profile. So let's go ahead and create a new traffic manager profile, and I'm going to call it my app service. Then I'm going to configure my traffic manager to use priority routing method. So I'm going to tell my traffic manager to use Sydney region at the highest priority. And if something happened in Sydney region, then traffic manager is going to direct the traffic to US region. And for the resource group, I'm going to host it in Sydney resource group. And let's go ahead and create my traffic manager profile. And until my traffic manager is created, let's go back to the Sydney app service and just to make sure it's working correctly. So click on the browse button here. As you can see here, it opens a website that's hosted in Sydney region. And I'm going to do the same with the app service we hosted in US region. By going to the resource and then click on browse, it's going to open the website that's hosted in US region. Now let's get back to Traffic Manager and refresh this page. As you can see here, my Traffic Manager has been created. So let's configure it. Let's click on my app service and let's go to endpoints. And in here, I'm going to add 2 endpoints. And they are going to be Azure endpoints. However, you can specify external endpoints as we mentioned before. I'm going to call it Sydney endpoint. And the resource type is going to be app service. And the target resource here is going to be the app service we have created in Sydney region. And I'm going to give it a priority 1. And let's add this endpoint to my traffic manager profile. Then let's go ahead and add another endpoint for US endpoint. And again, the resource type is going to be app service. And in this case, I'm going to choose US app service that I've created in US region. And I'm going to give it a priority 2. Let's go ahead and add this endpoint. So what I've done so far, I have configured my traffic manager to send the traffic primarily to Sydney region by configuring it or giving it a priority 1. At the same time, I configured the US endpoint with priority 2 to use it as a failover in case of anything wrong happen in Sydney endpoint. Now let's get back to the overview tab to test our changes. And as you can see here, there is a DNS name has been created for my traffic manager while I created my traffic manager profile. So let's copy it and paste it in a new browser tab. And as you can see here, it opened a web page for me. However, you can't tell exactly whether this is Sydney website or US website because they are exactly the same. So what I'm going to do now is to go to my endpoints and I'm going to disable Sydney endpoint. So let's click on Sydney endpoint and then let's disable it. Then let's save our changes. Now, based on my configuration, Traffic Manager should be sending the traffic now to US endpoint. Since priority 1, which is my Sydney endpoint, is not available anymore, Traffic Manager is going to send the traffic to the second priority, which is US region. Let's get back to refresh this page. As you can see here, I'm still able to see the US app service because I have configured my Traffic Manager to use the US endpoint as a failover endpoint in case anything wrong happened with the Sydney endpoint, which is my primary endpoint. This was a quick one to show you how you can use Traffic Manager profile to improve the availability of your web application. By using the priority routing method, you will be able to specify the priority of different web applications in different regions. Then the Traffic Manager is going to send the traffic according to the priority you have specified in your endpoints configuration. That's all I have for you in this video. Now let's go ahead and clean things up. So let's go to the resource groups. And then let's go ahead and delete Sydney resource group and US resource group. By deleting the resource group, it's going to delete all of the resources I have created in this resource group. As you can see here, it's going to delete Sydney App Service, Sydney App Service Plan, and the Traffic Manager. Let's go ahead and delete it. And I'm going to do the same with the US resource group as well. It's going to delete the US App Service and US App Service Plan. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. I think it's important to mention upfront, and probably I have said it before, that this course is hands-on, which means we are going to spend so much time on Azure portal, creating different resources like Azure VMs, App Service, and Traffic Manager. So you should expect you will need to pay some money to Azure at the end of the month, as you are creating these resources with me. And I really highly recommend that you follow along with me as you are watching my videos. To get the best outcome and to get the best value of my course, I suggest you follow along and apply what I am doing in your own subscription. And as I mentioned, you will need to pay some money to Azure. However, in my case, it wasn't too much. It was less than $10 if I remember correctly. However, if you are not ready to pay this money, please don't create anything on Azure and just watch my videos. Also, it's important to mention that I'm not a big fan of having many services hanging around till the end of the course. That's why you will find me creating an Azure resources at the beginning of a lecture and then doing some work on it, and at the end of the lecture, I delete and clean everything up. This is to ensure, first of all, you are going to pay minimum cost to Azure at the end of the month, and also not leaving many resources hanging around in case if you decided to take the course over a long period of time. This is just a quick heads up I want to highlight at the beginning. And now, let's continue our learning. I'll see you in the next video. Hi everyone. In this section, we are going to talk about Traffic Manager routing. And we are going to see the different routing methods we can configure for our Traffic Manager profile. So we are going to talk about Priority routing method, Weighted routing method, Performance routing method, Geographic routing method, Subnet routing, and Multi-value routing methods. All of the different routing methods that are available in Traffic Manager, we are going to cover them in this section. So let's dive straight into it, and I will see you in the next video. Thanks for watching. Hi everyone. In this video, we are going to see how can we implement Priority traffic routing method for Traffic Manager. But before we get into this, let's talk a little bit about why you want to implement Priority routing method for your Traffic Manager. First of all, to improve the reliability and availability of your solutions and services. So what's going to happen is that the Traffic Manager is going to send 100% of the traffic to the primary endpoint, which is going to have priority 1. And in case of any failure happened to the primary endpoint, then the Traffic Manager is going to send 100% of the traffic to priority 2, or the secondary endpoint. And in case of any failure happened to the secondary endpoint, then the Traffic Manager is going to send the whole traffic to the third endpoint, and so on. This is to ensure that if any failure happened to your primary endpoint or secondary endpoint, Traffic Manager is going to send the traffic to other endpoints to keep your services available and reliable. When we talk about the Priority routing method, it's important to notice that Traffic Manager does not distribute the traffic across different endpoints you have configured in your Traffic Manager. But instead, Traffic Manager sends the whole traffic to the primary endpoint. And if it fails for any reason, then the Traffic Manager is going to distribute the traffic or send the whole traffic to the secondary endpoint, and so on. And in order to be able to specify the priority for your different endpoints in your Traffic Manager profile, you need to specify them in the priority property. And the lower the number, the highest the priority. Like priority 1 will have the highest priority in your Traffic Manager profile, and priority 3 is going to have the lowest priority. Now let's go to the whiteboard and sketch what are we going to implement on Azure portal. First of all, we are going to create resources across 2 regions. So the first region I'm going to use is Sydney region, and this is going to be my primary region. Then the second region I'm going to use is US region, and this is going to be my failover region. And in Sydney region, I'm going to create App Service Plan, and I'm going to call it Sydney App Service Plan. Also, I'm going to host app service, and I'm going to call it Sydney App Service. And I'm going to do exactly the same for the US region. So I'm going to create an app service plan in US region, and I'm going to call it US App Service Plan. And also I'm going to create app service, and I'm going to call it US App Service. Then I'm going to create my Traffic Manager profile, and let's call it App Service Traffic Manager. And then the Traffic Manager is going to send the traffic to the Sydney region primarily. And in case of any failure happen to the primary region or primary endpoint that's hosted in Sydney region, then the Traffic Manager automatically is going to send the traffic to the secondary endpoint in US region, because I am configuring the Traffic Manager to send the traffic to the US region as a failover scenario in case of any issue happened to the primary region or primary endpoint. So this is what are we going to build on Azure portal. I just wanted to give you a quick overview of what are we going to build on Azure portal. So let's go back to the Azure portal. Now I'm going to create app service. Actually, I need to create 2 app services, one in Sydney region and the other one in US region. So let's go ahead and create a new app service. And let's create a new resource group for it. Let's call it Sydney Resource Group. And I'm gonna use the latest .NET version. And I'm gonna host it in Australia East region, Sydney region. And as you can see, I don't have app service plan. So let's go ahead and create a new app service plan as well. Now going to the next page for the deployment, I'm gonna disable the continuous deployment. Going to the networking, again, I'm gonna leave everything to the default values. Going to the monitoring, I am not going to enable application insights, and then going all the way down, and I missed some step in the basic tab. I need to specify a name for my app service. I'm gonna call it Sydney App Service Traffic Manager, for example. Now let's go all the way down to the Create tab, and let's go ahead and create my Sydney app service. While this is being created for me, let's go ahead and create another app service, and I'm going to host it in US. This time I'm going to use US resource group, which is going to be a new resource group that's being created. And for the web app name, I'm going to call it US App Service Traffic Manager. And then I'm going to use the latest .NET version available, and I'm going to host it in US East. Then I'm going to create a new app service plan for the US region. Then leaving everything to the default values, and I'm going to disable application insights here. And then let's go ahead and create the second app service in the US region. Now let's get back to the primary endpoint or the Sydney app service. It's still being in progress. So while we are waiting for this, let's go and create my traffic manager profile. So let's go ahead and create a new traffic manager. And I'm gonna call it my app service traffic. And for the routing method, I'm going to use priority routing method. And for the resource group, I'm going to use the Sydney resource group. And let's go ahead and create the traffic manager profile. While it's being created for me, let's go back and check the app service we have created in Sydney and make sure it's working fine. I'm gonna click on the browse button. As you can see here, it opened a website for me. And let's do exactly the same with the US app service, going to the resource and clicking on the browse button. As you can see here, I'm able to open a website for US app service as well. Now let's get back to the traffic manager, and I think now it's been created for me. That's right. Now let's get into the traffic manager and go to the endpoints. Now I am going to add different endpoints, Sydney app service and US app service, to my traffic manager endpoints. Then I'm going to specify the priority for each of these endpoints. Now let's go ahead and add the primary endpoint, and I'm gonna call it primary Sydney endpoint. And it's gonna be an app service, and I'm going to select it from here, and the priority is gonna be 1, which is gonna be the highest priority in the traffic manager profile. Let's go ahead and add this endpoint. Now let's go ahead and add the secondary endpoint, which is gonna be the US secondary endpoint. And it's gonna be app service, and I'm gonna choose the US app service, and I'm gonna assign priority 2. Let's go ahead and try assign a priority 1. As you can see here, we cannot assign the same priority to different endpoints because I used the priority 1 already for Sydney endpoint. So I'm gonna go for the second available priority, which is 2. However, I could choose 3 or any other value. And when the traffic manager find a failure in endpoint 1, then it's gonna go for the second highest priority, which is gonna be 3 or whatever I'm gonna specify. So let's specify priority 2, and let's go ahead and add the secondary endpoint for my traffic manager. Now let's go to the overview tab. And you can see here there is a DNS name for my traffic manager profile. So I'm gonna copy it and put it in the browser tab. And as you can see here, it opened a website for me. Now what if I go back to my traffic manager profile and disable the primary endpoint? So what's gonna happen is that the traffic manager will find the first or the primary endpoint is not available to send the traffic to it. Then the traffic manager is going to send the traffic to the second highest priority in the configuration. So in this case, the traffic manager is going to send the traffic to the US app service endpoint. Let's refresh this page to make sure that the endpoint is online. Now let's go back to the traffic manager URL and let's refresh this page. As you can see here, the traffic manager routed the traffic to the US app service. However, there is no difference between the app service or the website that's hosted in Sydney app service and US app service that you can tell. But having that, we have disabled the Sydney endpoint and we are still able to view the website that tells us that the traffic manager has routed the traffic to the US app service endpoint. This is how we can implement the priority traffic routing method for the traffic manager. Now let's go ahead and clean things up. So I'm gonna go for resource groups. And I'm going to delete Sydney resource group, which is going to delete all resources that's been created in Sydney resource group. And I'm going to do exactly the same for the US resource group as well. That's all I have for you in this video. We have seen how can we implement the priority traffic routing method for traffic manager profile. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the weighted traffic routing method for your traffic manager profile, which allows you to distribute the traffic either evenly or according to a predefined weighting that you have configured in your traffic manager profile. And the way it works is that you will have to specify weight for every endpoint in your traffic manager profile. And the higher the weight, the higher the priority. For example, region A and region B endpoints has the weight set to 50, while test A endpoint had the weight set to 5. Which means that region A and region B endpoints are going to receive traffic 10 times the traffic that test A endpoint is going to receive. This is according to our configuration. Having said that, you don't have to specify weight for your endpoints. However, if you didn't, then the traffic manager is going to apply the default weight, which is going to be 1 for your endpoint in your traffic manager profile configurations. And when the traffic manager profile receives a DNS response, then the traffic manager is going to distribute the traffic randomly to the endpoints in the traffic manager profile. And the probability of choosing the right endpoint, it's gonna reflect on the weight you have specified already in your endpoint. And as I said before, the higher the weight, the higher the priority of the endpoint. And if you specify the same priority or the same weight across all endpoints in your traffic manager profile, that means that your traffic manager is going to distribute the traffic evenly across all endpoints in your traffic manager profile. And as I mentioned before, the higher the weight, the higher the priority. And according to these settings we see in front of us here, region A and region B endpoints are going to receive more traffic than test A endpoint according to the weight we have specified for our endpoints. And there are few situations you want to consider using the weighted routing method. First of all, when you want to have a gradual application upgrade. For example, you deploy the new endpoint and you want to gradually shift the traffic to the new endpoint. So you are going to be starting from 10% of the traffic getting to the new endpoint, and after production testing and you get confidence in the new release, then gradually you shift more traffic to the new endpoint until it reaches 100%. And that's why Traffic Manager is very famous with the blue-green deployment, which allows you to have blue version and green version of your deployment and shift traffic gradually to the new version of your applications. Also, the second scenario when you want to consider using the weighted routing method is when you want to perform an application migration to Azure. So in this case, you are going to create a Traffic Manager profile with both Azure and the external endpoints, and then gradually you are going to adjust the weight to move it completely to the Azure endpoints instead of on-prem endpoints. And the third situation you want to consider using the weighted routing method is when you want to do cloud bursting for more capacity, which allows you to expand on-premise deployment into the cloud by putting it behind the Traffic Manager profile. And when you need an extra capacity, you can adjust the weight into the Azure endpoints. Now it's important to mention that the DNS responses get cached at the client side and at the recursive DNS servers, and this caching can have an effect on the weighted traffic distribution. So when the number of the clients or recursive DNS servers is large, then the traffic distribution is going to work as expected without any issues. However, when the number of clients or recursive DNS servers is small, then caching can significantly disrupt the traffic distribution for your weighted routing method. And this usually happens in development or testing environment, or when you do an application-to-application communication, or when your application is aimed at a narrow user base that share a common recursive DNS server. And the DNS caching I just mentioned is not something specific to Azure Traffic Manager. It's common across all DNS-based traffic routing systems. And if this doesn't work for you, then you might need to consider using an alternative traffic routing method that can be more appropriate for your use case. Now, let's go to the whiteboard and sketch what are we going to implement on the Azure portal to help us understand the weighted routing method of the Traffic Manager profile. The first thing we are going to work across two regions. First region, I'm going to use Sydney region, the primary region. Then in Sydney region, I'm going to create resource group. I'm going to call it RG Sydney. And then I'm going to create VNet. I'm going to call it VNet Sydney. Then I'm going to do exactly the same in US. So US is going to be my second region. And I'm going to create a resource group in US region and a new VNet as well in the US region. Then I'm going to provision few VMs. First VM, it's going to be an IIS VM, and I'm going to call it Sydney VM IIS. And then I'm going to provision a test VM in Sydney region as well, and I'm going to call it Sydney VM Test. And I'm going to do exactly the same in the US region, creating a VM, call it US VM IIS, where I'm going to have an IIS server on this VM. Then also I'm going to provision a test VM in US region, and I'm going to call it US VM Test. Then I'm going to create Traffic Manager profile, and I'm going to use weighted routing method. And I'm going to configure it in a way when the Traffic Manager receives the traffic from Sydney region, for example, then Traffic Manager is going to send a portion of the traffic to the IIS server in the Sydney region. At the same time, the Traffic Manager is going to send the majority of the traffic to the IIS server in the US region. This is what I meant that we are going to configure, or we are going to use the weighted routing method of our traffic manager profile. It doesn't matter from where the traffic is coming from, whether from Sydney or from US. I have configured my traffic manager to send the majority of the traffic to the IIS server hosted in US region, and then sending a small portion of the traffic to the IIS server that I hosted in Sydney region. This is what the weighted routing method is about. Now let's go to the Azure portal and implement this solution. Now the first thing I'm going to do is to create few VMs. So I'm going to create 4 virtual machines. Create a new virtual machine, and I'm going to create a new resource group in Sydney region. And then I'm gonna call this VM Sydney IIS, and I'm gonna host it in Australia East region, which is Sydney region. Then I'm going to choose Windows Server 2019, then specify a username and password for my VM. And I'm going to leave port 3389 open, the RDP port. However, you should never do this in production environment. Now going to the networking, and I'm going to create a new VNet in Sydney region, and let's go all the way down and go ahead and create our VM. Now, let's go ahead and create a second VM in Sydney region. And I'm going to use the resource group I just created before. Now, I'm going to specify a VM name to be VM Sydney Test. And I'm going to host it in Australia East region. And I'm going to use Windows Server 2019. Then I'm going to specify a username and password for my VM, leaving the RDP port open, then going to the networking, making sure it's going to use the same VNet I just created before, and then going all the way down and go ahead and create my test VM in Sydney region. Now let's go ahead and create another VM in US region. So I'm going to create a new resource group. I'm going to call it RGUS. And I'm going to call my VM name to be VMUSIIS. And I'm going to host it in Eastern US region. I'm going to choose Windows Server 2019. Then I'm going to specify a username and password for my VM, and I'm going to leave the RDP port open. Then going to networking, I'm going to create a new VNet for the VM in US region. Then going all the way down, and let's go ahead and create my IIS VM in US region. Now I need to create one more VM in US region, which is going to be my test VM. So let's go ahead and create it. Again, I'm going to use the US resource group, and I'm going to call it VM US test. I'm gonna host it in Eastern US region. I'm going to choose Windows Server 2019 and specify username and password for my VM. I'm going to leave port 3389 open, the RDP port. Then going to the networking, making sure it's going to use the same VNet I just created before. Then going all the way down, and let's go ahead and create our VM. Now let's get back to Sydney IIS VM. And let's go ahead and open the cloud terminal or cloud shell to install IIS on this VM. Alright, and now let's run this command. Let's paste this command that I'm going to leave in the description box. And I'm going to specify a resource group name here, which is going to be rg-sydney. And then the VM name, It's going to be VM Sydney IIS. And location is Australia East. And let's go ahead and execute this command to install IIS on this VM. And let's go to US IIS VM. And let's do exactly the same. Let's open the Cloud Shell. And let's execute the same command. Now I'm going to put the resource group name to be RGUS. And the VM name is going to be VMUSIIS. And of course I need to change the location to be East US. And let's go ahead and execute this command as well to install IIS on the VM. Alright, now the IIS has been installed in the US VM as well as Sydney VM. So let's go ahead and configure the DNS name for Sydney IIS VM. I'm gonna call it VM Sydney IIS. And let's go ahead and save our changes. And let's go to the US VM and go ahead and define a DNS name as well. I'm gonna call it VM US IIS. And then let's go ahead and save our changes. And now let's go to the overview. This is a public IP address, so let's go to the VMs and open US IIS VM. And let's go ahead and copy the DNS name of my VM. And from previous video, you know that we will not be able to view this page. And the reason for this is that we still need to enable or allow the inbound traffic coming on port 80. So let's go ahead to networking. Let's add a new inbound rule. So I'm going to add it on port 80, priority 310, and the name is going to be HTTP. And let's go ahead and add this rule. And let's add the same rule in Sydney VM as well. IIS VM. Let's go to networking. Let's add a new inbound rule on port 80, accepting all traffic on port 80. And I'm going to call it HTTP rule. And let's go ahead and add it. Now going to the DNS name and let's refresh this page. According to the changes I just done, I should be able to view the IIS page, the default IIS page on the US VM IIS. As you can see here, this is the default page in my US IIS. And let's test exactly the same in Sydney VM IIS to make sure that we have configured everything correctly. As you can see here, this is the name of my Sydney IIS VM. Alright, now let's go ahead and create our traffic manager profile. Let's go ahead and create a new one. And I'm gonna call it weighted traffic manager. And I'm going to choose the weighted routing method. I'm going to use Sydney Resource Group. And let's go ahead and create my traffic manager profile. And now let's go ahead and define our endpoints. Let's go to endpoints and let's go ahead and add a new endpoint. I'm gonna call the first one Sydney endpoint, and it's gonna be based on a public IP address. And I'm going to choose the public IP address I created for Sydney IIS VM. And I'm going to specify a weight 25. Let's go ahead and add this endpoint. Then let's add another endpoint. I'm gonna call it US endpoint. And I'm going to make the target resource type to be the public IP address of the VM of the US IIS VM to be specific. And the weight here is gonna be 100. And let's go ahead and add the second endpoint. And let's wait for a few seconds until Traffic Manager checking the endpoints and make sure that they are healthy. Alright, now the two endpoints are now online and available for me, so let's go to the Overview tab in my Traffic Manager profile and let's copy the DNS name of my Traffic Manager. And let's put it in a new browser tab. As you can see here, it opened USIIS. And as I'm refreshing the page, it still views the USIIS because this is where I specified the highest routing or highest weight. So let's go ahead and adjust it a little bit to just make us be able to see the result. So I'm going to change the weight to be 50 in Sydney region instead of 25. And I'm going to leave the weight to be 100 for US region. So now we should be able to see some traffic gets routed to Sydney IIS. And as you can see here, every now and then the traffic manager is going to send some traffic to Sydney IIS VM because this is how we configured our traffic manager profile to send less traffic to Sydney IIS VM compared to US IIS VM. This is all I have for you for the traffic manager weighted routing method. Now let's go ahead and clean things up. Let's go and open resource groups. And let's delete Sydney resource group, which is going to delete all resources I created in this resource group. And also let's go ahead and delete US resource group. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the performance traffic routing method for Traffic Manager. But before we get into it, let's talk a little bit about why do you want to use performance routing method. The main reason to use it is to improve the responsiveness of your application by deploying your application endpoints in different Azure regions, and then using Traffic Manager to direct the traffic or direct the incoming requests to the closest Azure region. And when I say the closest Azure region, I don't mean closest from the geographic perspective, but closest from the network latency perspective. So you might have a user located in US, and you already have an endpoint in West US region. But based on the latency table that we are going to talk about in a minute, based on the latency table, Traffic Manager might decide to forward the traffic to North Europe region because it might provide lower latency compared to US region. And this is just an example. So what is the latency table that I mentioned before? The latency table is something that Azure manages, putting the different IP ranges for different Azure data centers or regions. And then it's going to provide the different latency for each of these regions. This is going to help a Traffic Manager to decide which region is going to provide the lowest latency for different requests coming from a specific IP ranges. And for the latency table, you don't need to worry about it. Azure manages it and updates it regularly to make sure it reflects the reality. Now, there are few things you need to be aware of when you are using performance routing method. First of all, if you are hosting your endpoints in one Azure region and you have configured the Traffic Manager to use performance routing method, what's going to happen in this situation? That the Traffic Manager is going to distribute the traffic evenly across all available endpoints in that region. However, if you prefer to specify a different traffic distribution, you can use nested Traffic Manager profiles, which we are going to see in more details in the advanced section. And if all endpoints in one region become unavailable for any reason, then the Traffic Manager, with the help of the latency table, is going to move the traffic to the endpoints in the next closest region. And if you want to specify a specific failover sequence, you can do this by using a nested traffic manager profile, which is again, we are going to see it in the advanced section. Generally speaking, repeated DNS queries coming from the same client are going to be directed to the same endpoint. However, this is not always the case, because when the client is using recursive DNS servers when traveling through the internet, the client might get routed to a different endpoint and also are gonna get through a different DNS servers. That's why there is no guarantee that the client is always get routed to the same endpoint. This is something you need to be aware of when you are using performance routing methods. And the last thing I want to mention here is that the latency table gets updated regularly by Azure. So you might notice that the same client get directed to different endpoints, and this happens because there are some updates happened to the latency table. These are the main things I want you to be aware of when you are using performance routing methods for your traffic manager profile. Now, let's go to the whiteboard and sketch what are we going to do in the Azure portal before we go ahead and implement it. So what are we going to do is to deploy some VMs across two regions, and then using Traffic Manager to distribute the traffic based on the lowest latency. So the first region I'm going to go for is going to be Sydney region. And inside Sydney region, I'm going to create a resource group. Let's call it RG Sydney. And then I'm going to create a VNet for the VMs that I'm going to create. And the other region I'm going to use is US region. And I'm going to create a resource group for US region as well as a VNet as well. And in Sydney VNet, I'm going to create one VM. Let's call it Sydney VM IIS. This is where I'm going to host an IIS server. Then I'm going to create another VM in Sydney VNet. And I'm going to use this VM to test the IIS server. And let's call the test VM Sydney VM test. And let's do exactly the same thing in the US VNet. Let's create a VM and call it US VM IIS. And the other VM that we are going to use to test the IIS VM in US region, we are going to call the VM US VM test. Then we are going to create traffic manager profile, and we are going to configure it based on the performance routing method. So when the traffic manager receives an incoming request coming from Sydney VM test, then the traffic manager is going to route this request to Sydney VM IIS, because this VM is going to provide the lowest latency for the incoming request. And similarly, when we send a request from the US VM test, traffic manager is going to route it to US VM IIS, because this is the VM that's going to provide the lowest latency for the incoming request. Of course, if we take it to the next step and we disable Sydney VM IIS altogether, and we send a request from Sydney VM test, then the traffic manager is going to send the traffic to US VM IIS, because this is the only available IIS VM we have in both regions at the moment. And we are going to see it in more details when we implement it in Azure portal. This is just to give you a quick overview of what components we are going to build in Azure portal. Now let's go to Azure portal and build our solution. And now let's go ahead and create 4 VMs, 2 VMs in each region. So let's go ahead and create a VM. And I'm going to create a new resource group for VMs in Sydney region. I'm gonna call it RG Sydney. And the VM name is going to be VM IIS Sydney. And I'm going to host it in Australia East region. And I'm going to choose Windows Server 2019, and I'm going to specify my username and password for the VM. And I'm going to leave port 3389 open, the RDP port that allows me to connect to the VM if I wanted to. However, you should never do this in production environment. You should always go for Bastion host. However, I'm not going to do it for this exercise. Now let's go to the networking, and I'm going to create a new VNet in Sydney region, and let's go all the way down and create my IIS VM in Sydney region. Now let's go ahead and create a second VM in Sydney region, and I'm going to use the resource group I just created. I'm going to call it VM test Sydney. And I'm going to use Windows Server 2019, and I'm going to specify a username and password for my test VM. And again, I'm going to leave RDP port open, going to the networking, make sure that it's gonna use the same VNet I just created before, and let's go all the way down and create my test VM in Sydney region. Now I'm going to do exactly the same for US region. So I'm going to create a VM on US region, and I will need to create a new resource group for US region. I'm gonna call it RGUS. Then I'm gonna call the VM name to be VMIISUS, and I'm going to host it in Eastern US region, and I'm going to use Windows Server 2019, and again, I'm going to specify a username and password for my VM. And again, leaving port 3389 open, going to the networking, I will need to create a new VNet for the US region, and then going all the way down and create my IIS VM in US region. And let's go ahead and create it. Then I have one more VM to create. I'm going to create one test VM in US region as well. So let's go ahead and do that. So I'm going to put it in the resource group I just created for the US region, and the VM name, I'm gonna make it VM test US, and I'm gonna host it in Eastern US region. Then I'm going to use Windows Server 2019. Then I'm going to specify my username and password for the test VM. Leaving port 3389 open, then going to the networking, making sure that it's going to use the VNet I created recently for the US region, then going all the way down and go ahead and create my test VM in the US region. Now let's get back to my IIS VM that I created in Sydney region, and as you can see, it's now ready for me. I'm going to open the Cloud Shell to run some commands to install IIS on this VM. And I think I will need to do the same in the US IIS VM as well. Let's open a Cloud Shell terminal here as well. Now I'm going to put this command here, which I'm going to leave in the description box. And what I need to do here is to specify the resource group name. And for this VM, it's going to be RG Sydney. And the VM name, it's going to be VMIIS Sydney. Let's go ahead and run this command. And as you can see here, I'm going to adjust the default page in the IIS server to display the computer name or the VM name when I access it. And let's do exactly the same with the US IIS VM. Let's paste the same command, and again specify the resource group name to be RGUS, and then for the VM name I'm going to use VMIIS, and let's go ahead with that. And as you can see here, I specified the wrong location for the US VM. So what I need to do is to specify East US instead of Australia East, because this is not the right region for this VM. Let's give it a go one more time. Alright, now the IIS has been installed in the US VM as well as on Sydney VM. Now there is one more step that we need to do, is to specify the DNS name for the IIS VMs. So I'm gonna go ahead and type in VM IIS Sydney. And let's go ahead and save this DNS name. And let's do the same with the US region as well. So let's configure a DNS name. I'm gonna type in VM IIS US region. And let's go ahead and save my changes. Now, on the IIS Sydney VM, let's get back to the overview tab. This is a public IP address, so I need to get back to my VM. Going to the overview tab of my IIS Sydney VM, and let's copy the public DNS name that I just created. And you'll see that we are not able to access it, even though we have created a DNS name and we have a public IP address and we have IIS installed on that VM, as you can see here. And the reason for this, because we need to enable the incoming traffic on port 80. So I'm gonna accept any traffic coming from any port. I'm gonna direct it to port 80. I'm gonna give it priority 300 or 305, and then I'm gonna call it IIS port. And let's go ahead and add this to my inbound rules. And after it's been created, I'm gonna give my DNS name one more go and see if I will be able to access it. Now, let's go to my DNS name for Sydney VM and let's refresh my page. And as you can see here, I was able to view my page. So let's do exactly the same with US IIS. I have already specified the DNS name for my VM IIS in the US region. So let's go back and allow, again, this is my public IP address. So let's go back to my VM and going to the networking, allow inbound rule on port 80. And I'm gonna call it IIS port. Let's go ahead and add this inbound rule. And after it's been created, I'm going to double check that I'm able to access the DNS name for my US IIS VM. So let's open a new browser tab and let's put the DNS name of my US IIS VM. And as you can see here, I'm able to access it as well. So far, so good. The next step for me now is to go ahead and create a traffic manager. So let's create a traffic manager profile, and I'm gonna call it IIS VM traffic. And I'm going to choose performance routing method, which is the default option that's been already selected for me. And I'm going to use Sydney resource group that I've created before. And let's go ahead and create the traffic manager profile. Alright, now the traffic manager has been created for me, so let's go ahead and define my endpoints. And I'm going to add 2 endpoints. The first endpoint is going to be Sydney endpoint. And I'm going to make my target resource type here to be public IP address. Then I'm going to choose the public IP address of my Sydney IIS VM. Let's go ahead and add this endpoint. Then let's go ahead and add the US endpoint as well. I'm gonna call it US endpoint, and the target resource type is going to be public IP address. Then I'm going to choose the public IP address of the US IIS VM. And let's go ahead and add the second endpoint. Alright, both endpoints are now online, so let's go ahead and test what we have done. So this is the test VM that I created in Sydney region. I'm going to go ahead and connect to it using RDP. So I'm gonna download an RDP file to allow me to connect to test VM in Sydney region. So let's go ahead and specify my username and password, and let's connect to Sydney VM. And I'm going to do exactly the same with the US test VM as well. So let's go to my test VM in US region and let's connect to it using RDP connection. And let's download an RDP file that allows me to connect to the VM. And let's specify my username and password to connect to US test VM. Now, going back to Sydney test VM, what I need to do now is to disable enhanced internet security configurations that allows me to browse using Internet Explorer more easily. So now I'm going to open Internet Explorer. Ask me later. Now I'm going to go for the test VM in the US region, and I'm going to disable enhanced internet security configurations on the server to allow me to browse Internet Explorer more easily. By going to the local server, and let's click on IE enhanced security configuration, and let's turn it off for the administrators and all users. And now let's go ahead and open Internet Explorer as well in the US test VM. Now let's get back to my traffic manager profile and let's go to the overview tab. Now I'm going to copy the DNS name of my traffic manager. And let's go to Sydney region test VM. And I'm going to paste the URL in there. As you can see here, from the test VM in Sydney region, I've been directed to the IIS VM in Sydney region because this is the lowest latency that the traffic manager has found. And when I go to the US test VM and put the same URL, which is the traffic manager URL, I'm going to get directed to the US IIS VM because this is the lowest latency endpoint that the traffic manager has found. Now let's get back to the whiteboard and talk about what we have done. So we have sent an incoming request from a Sydney VM to the traffic manager DNS name. And based on our configuration for the traffic manager now sends this request to Sydney IIS VM because this is the lowest latency endpoint that the traffic manager was able to find. Similarly, when we send a request from a US test VM to the traffic manager DNS name, then the traffic manager sends this request to the US VMIIS because this was the lowest latency endpoint that the traffic manager was able to find. Now let's take it one step further and let's go back to the traffic manager profile and let's go to the endpoints, and now I am going to disable Sydney endpoint to just show you what's going to happen. Now let's go ahead and open my Sydney test VM and let's refresh this page. And as you can see here, my request coming from Sydney test VM has now been directed to the US IIS VM because this is the only endpoint that's available in my traffic manager configuration. This is to show you how you can configure traffic manager to use performance routing method, so it will be able to direct different requests to the closest endpoint. And again, when I say closest endpoint, I don't mean a closest from a geographic perspective, but I mean closest from network latency perspective. That's all I have for you in this video. I hope you enjoyed it. Now let's go ahead and clean things up. So what I'm going to do now is to go for the resource groups, and I'm going to delete both resource groups I've created in Sydney region and in the US region as well. So I'm gonna type in the resource group name, and it's going to delete all resources I have created in Sydney region. And I'm going to do exactly the same with the US resource group as well. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video we are going to talk about geographic traffic routing method for traffic manager profiles. And we are going to see how can we configure our traffic manager to send the traffic to a specific endpoint based on the region where the traffic is originating from. And we are going to see it in more details in this video. So let's have a look at our traffic manager here in this diagram and the way we configured it. So we have configured our traffic manager to send the traffic to endpoint 1 if the source IP address is coming from Germany. And we have configured the traffic manager to send the traffic to the nested profile here, which is, by the way, we are going to see it in more details in the advanced section, if the traffic is originating from Mexico or Asia. And then we have configured the catch-all scenario for the traffic manager to send the traffic to endpoint 2 if the traffic is originating from anywhere in the world. So if we have a user in Germany send the request to the traffic manager, it's going to go through the recursive DNS service and then landed on the traffic manager. Based on our configuration, we would assume that the traffic manager could send the traffic to endpoint 2 because the user is in Germany and Germany is part of the world. And let's have a little pause here, as you might think that there is a confusion in our configuration because Germany, Mexico and Asia are considered to be part of the world. So when a user in Germany is going to send the traffic to the traffic manager, then the traffic manager is going to consider Germany is part of the world. Then the traffic manager is going to direct the traffic to endpoint 2, which is going to make endpoint 1 and nested profile redundant. But this is not how traffic manager works. Traffic manager is going to send the traffic based on the lowest level of granularity. So what does it mean? So if we have a user in Germany send their traffic to the traffic manager, and the traffic manager finds that the source IP address of the query is coming from Germany, then the traffic manager is going to send the traffic to endpoint 1 because based on our configuration here, we have specified if the traffic is originating from Germany, then the traffic manager should send the traffic to endpoint 1. And this is more granular than the world endpoint. And same scenario, if we have a user in Asia, send the request to traffic manager because we have a more explicit configuration for traffic originating from Mexico and Asia, then the traffic manager is going to send the request to the nested profile endpoint. However, if we have someone living in Sydney, for example, which is not in our traffic manager configuration, then the traffic manager is going to send the request to endpoint 2 because we have configured it to be the catch-all for any request coming from anywhere in the world. We are going to understand this in more details in this video. So now let's go to the whiteboard and let's sketch what are we going to build in Azure in this video. So we are going to use two regions in this video. First region is going to be Sydney region. Then we are going to create a resource group in Sydney region. And then we are going to create a VNet in Sydney region. Then we are going to create a VM. We are going to call it Sydney VM IIS. And we are going to create another VM. We are going to call it Sydney VM test. And then we are going to do exactly the same in another region, in US region. We are going to create a resource group, and then we are going to create a VNet in US region. Then we are going to create an IIS VM and a test VM as well. Then of course we will need to provision traffic manager. So when we send a request from US test VM to the traffic manager, then we are going to configure the traffic manager to send the traffic to Sydney VM IIS. and we are going to use the geographic routing method here, and we are going to see it in more details. And also we are going to configure the traffic manager to route the traffic coming from Sydney VM test and push it to US VM IIS. So when the traffic manager is going to receive a request from Sydney region, simply we are going to configure the traffic manager to send it to US IIS and the other way around as well. And this is going to help you understand the difference between geographic routing method or performance or latency routing method. Because in the previous videos, we have configured the traffic manager to route the requests coming from Sydney VM test to Sydney VM IIS, because this is the lowest latency that the traffic manager was able to find. But in this video, we are going to configure it differently to just show you how you can play around with the configuration based on where the traffic is originating from. Now let's go to the Azure portal and see how can we build this solution. Now let's go and create VMs. And I need to create 4 VMs, 2 in Sydney, 2 in US. Now my first VM here, I need to create a new resource group. I'm gonna call it RG Sydney. And I'm gonna call it Sydney VM IIS. I'm gonna choose Windows Server 2019. I'm gonna select username and password. And I'm gonna leave port RDP port open. Now let's go to desks. Leave everything to the default values. For the networking here, have a look at the new VNet that's gonna be created for you. And then let's go all the way down to review and create. And then let's go ahead and create our Sydney IIS VM. And now let's go ahead and create another test VM in Sydney region. Now let's select RG Sydney resource group. I'm gonna call this VM Sydney VM test, and then I'm gonna select Windows Server 2019, and I'm gonna specify a username and password for my test VM, and then I'm gonna leave RDP port open. Then going to networking and having a look and making sure that we are using the same VNet configurations we have used before, and then let's go all the way down and create our test VM in Sydney region. Now let's go ahead and create another VM in US, and we will need to create a new resource group for that. Let's call it RG US, and I'm gonna call it US VM IIS, and I'm gonna host it in US East. I'm gonna select Windows Server 2019, and I'm gonna specify my username and password for this VM. I'm gonna leave port RDP port open as well, going to networking, having a look at the new VNet that's gonna be created for me because we don't have VNets in US region. Let's go all the way down and create my US VM IIS. Now we have one more VM to create, which is US test VM. So let's go ahead and do it. Now I'm going to select US resource group, and I'm going to put US VM test. And then I'm gonna put it in Eastern US region, and I'm going to select Windows Server 2019. And I'm going to specify my username and password. I'm going to leave RDP port open, going to networking, making sure that we are going to use the same VNet we have created in US region. And then let's go all the way down and create US test VM. Now my Sydney IIS VM has been created, so let's open a Cloud Shell terminal. to install IIS on Sydney IIS VM. And I'm going to use this script here that I'm going to leave in the description box, and I need to specify the resource group name. And let's go to the resource here so we can get this information. So the resource group name is going to be RG Sydney, and then the VM name, it's going to be Sydney VM IIS. And let's go ahead and execute this command. And while we are waiting for this, let's go ahead to US IIS VM, and let's open another Cloud Shell terminal, and let's install IIS on the US IIS VM as well. So let's paste this command, and let's specify the resource group name. It's going to be RGUS. And the VM name, it's going to be US VM IIS. It's dash here. And let's go ahead and execute this command. As you can see, it will not work. It should come with an error because I didn't change the location here. I need to change the location to be East US, because this is the region that I used for the US VMs. Let's execute this command to install IIS on the US VM IIS. And while we are waiting for this, let's go and create a traffic manager profile. So let's go to traffic manager and let's create a new traffic manager profile. So I'm gonna call it Geo Profile Test. And then I'm going to specify geographic routing method, and the resource group, I'm going to put it in Sydney. And then let's go ahead and create the traffic manager. Alright, now the IIS has been installed on Sydney VM IIS. The next step I need to do is to configure a DNS name for the VM. So let's go to DNS and put Sydney IIS VM, for example. And this name is free. And let's go ahead and save our changes. And let's go back to the overview tab. Probably I need to go back to the VM itself because this is the IP address. And let's go to networking and let's allow inbound traffic. Probably let's close the terminal. I wouldn't need it anymore. Now let's allow inbound traffic on port 80. This will allow us to display the HTML page we have created as we have ran this script. Now let's go back to our US IIS VM, and our IIS has been installed. Let's close the Cloud Shell terminal and let's configure a DNS name for US IIS VM. I'm gonna say US IIS VM. And let's go ahead and save our changes. And let's go back to the VM and go to networking. And let's go ahead and add a new inbound rule on port 80. And let's go ahead and add this rule. Now, what we need to do now is to go to our traffic manager profile and let's refresh this page. So we will be able to configure our traffic manager to send the traffic to different endpoints. So the first endpoint I'm going to add here is going to be Sydney endpoint. And the target resource type is going to be public IP address. And I'm going to choose the Sydney public IP address, Sydney IIS VM. And here I get to specify the originating traffic. And in this case, I'm going to specify it. We will be able to specify traffic coming from the whole world, which is a good use case to be used as a catch-all scenario. But in this example, I'm going to specify North America, Central America, Caribbean. Any traffic is coming from this region. then I'm going to send it to Sydney VM. I know that's confusing, but I just want to make a point. I'm directing the traffic to the farthest region in our architecture. And we can leave it there, or we can take it to the next step and specify to which country or which state or province we are expecting the traffic is originating from. However, I'm going to keep it like that, and then I'm going to add this endpoint. Then we will need to add another endpoint. I'm going to call it US endpoint, and I'm going to choose public IP address, and I'm going to select the US IIS IP address. And for the regional grouping here, I'm going to select the originating traffic coming from Australia or Pacific. And if any traffic is coming from this region, then it's going to get directed to US VMIIS. Let's go ahead and add this endpoint as well. Now let's go to my test VM in Sydney, and let's connect to it using RDP. Let's download a file, and let's connect to my Sydney test VM. And let's do exactly the same with the US test VM as well. Let's go to the resource and connect using RDP and download the file. Let's connect to US test VM. Now let's go ahead and disable the advanced security configurations for our Internet Explorer so we can test our scenario. So let's turn it off for all users, and let's do the same in Sydney test VM as well. Going to all servers and turn off enhanced security configurations. Now, let's go back to our traffic manager profile. As you can see here, both endpoints are online. So let's go back to the overview tab. Let's copy the DNS name of our traffic manager profile. And let's go to Sydney test VM. Let's open Internet Explorer and let's paste the DNS name. As you can see here, as the traffic is originating from Sydney, and according to our configurations we have done to the traffic manager sent the traffic coming from Sydney to US IIS VM. And if we go to the US test VM and open Internet Explorer and paste traffic manager DNS name here as well, we will be able to see that the traffic manager is going to direct the traffic to Sydney IIS VM. So this is how can we configure the traffic manager to send the traffic based on the geographical traffic routing method. And it's very powerful in some scenarios. Now let's get back to the traffic manager and go to the endpoints. And let's go ahead and add a new endpoint. And in this case, I'm going to select an external endpoint. I'm going to call it Google, and I'm going to send the traffic to google.com. Now, I'm going to select the originating region to be Australia Pacific. And if you remember, we have already configured one of these endpoints to route the traffic coming from Australia Pacific to US endpoint. And let's go ahead and add this. As you can see, Azure Portal didn't allow me to add this endpoint because it is confusing. We have already an existing endpoint that are going to direct the traffic to US VMIIS if the traffic is coming from Australia. And now we are telling Traffic Manager something different. We are configuring Traffic Manager to send the traffic to google.com if the traffic is coming from Australia or Pacific region. So in this case, we need to be more specific. So we need to go one step further and select a country to help the Traffic Manager to distinguish between the requests coming from these two endpoints. And let's go ahead and try to add it. as you can see, it is still confusing. Traffic Manager cannot or will not be able to decide based on these two configurations only, the region and the country, which endpoint they should be able to send the traffic to. And if I'm gonna go one step further and specify a state, and then let's go ahead and try to add this endpoint, in this case, Traffic Manager will be able to make a distinguish between our configuration. And since Australia is already listed into endpoints, then in this case, the Traffic Manager, as we said before, is going to go for the lowest level of granularity, which means if a traffic is coming from Sydney, which is part of New South Wales, then the Traffic Manager is going to send it to Google endpoints. However, if the request is coming from anywhere else in Australia, then the traffic is gonna go through to the US IIS VM. And as you can see here, now after I have been more specific on specifying the endpoints, I was able to add it to my Traffic Manager endpoints. So let's go ahead and delete the Google endpoint. Now we want to test what's going to happen if one of these endpoints became disabled. Like let's go to Sydney region, for example, and let's disable this endpoint, and let's go ahead and save our changes. And as you can see here, Sydney endpoint is going to send the traffic to Sydney VM IIS. So we are going to go to the US test VM and try to refresh this page and see what are we going to get. Okay, we have some browser caching. So let me copy the URL and go to private browsing. And as you can see here, we are not able to reach this page. And the reason for this, because we have disabled the Sydney endpoint, which is the only endpoint that sends the traffic to the VM IIS in US region. So that's why it's going to be very important to add one endpoint to the whole world as a catch-all scenario. This is to cover you from any user joining from any region in the world that you haven't explicitly specified or configured on your Traffic Manager, and also to mitigate the risk of one of these endpoints became disabled or unavailable for any reason. The users in this region will still be able to hit through to the world endpoint that you have configured in your Traffic Manager profile. So going back to our whiteboard, this is what we have done in this video. We have configured our Traffic Manager to send the traffic coming from US VM to Sydney IIS and the other way around. This is to show you how can we configure the Traffic Manager to do geographic traffic routing method. Now, that's all I have for this video, so let's go ahead and clean things up. So let's go to the resource groups and go into Sydney resource group, and let's delete the resource group. And as I'm deleting the resource group, it's going to delete all resources I've created in this resource group. And I'm going to do exactly the same with the US resource group. It's going to delete all resources we have created in this resource group. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about subnet traffic routing method in Traffic Manager profile. And it's quite easy and simple. So when we create a Traffic Manager profile, we are going to specify subnet traffic routing method. And when we do that, we will have an option to specify a certain CIDR range for the incoming traffic. And if any request matches the CIDR range we have specified in our Traffic Manager profile, then the Traffic Manager is going to direct the traffic to a particular endpoint. Now let's go ahead and see how can we do this in Azure portal. Let's go ahead and create a Traffic Manager profile. And I'm gonna call it subnet routing test. And the routing method here, I'm going to select subnet routing method. Or for the resource group, I'm going to create one. I'm gonna call it RG Sydney. And let's go ahead and create our traffic manager profile. While we are waiting for this, let's create a VM in Sydney region, which we are going to install the IIS on it. So let's go ahead and create a new VM, and let's select Sydney Resource Group. Let's call the VM Sydney IIS. And let's select Windows Server 2019, and let's specify a username and password for my VM. Now let's leave RDP port open, go into networking, having a look at the new VNet that are going to be created for us. And then let's go all the way down and create our VM. Now my VM is ready for me, so let's open a Cloud Shell terminal. And let's run this script that are going to install IIS server on this VM. Of course, we need to do some adjustments. I need to specify the resource group name. So let's firstly go to the VM so we can get this information. It's RG Sydney, and then I need to specify the VM name, which is going to be Sydney IIS. And now let's execute this command. Alright, now the IIS has been installed on the VM, so let's go ahead and configure a DNS name for my VM. Let's call it Sydney IIS, and let's go ahead and save my DNS name. And let's close the Cloud Shell terminal here. And now let's go back to our VM. Let's enable inbound traffic on port 80 to allow us to access the IIS default page. And now our Sydney IIS VM is ready for me. I'm gonna copy this DNS name just to validate it's configured properly. And as you can see here, it loads the default page on the IIS server. Now let's go back to the traffic manager profile and let's go and add a new endpoint. Let's call the endpoint Sydney endpoint, and let's select a public IP address, and let's select the public IP address we have created for Sydney VM. So far, everything is pretty much similar to what we have done before in the other routing methods. The only difference I want to call out here is the subnet routing settings. When you select subnet routing method for a traffic manager profile, you will have an option to specify subnet routing settings. So let's say, for example, I'm going to put a CIDR range here. And what this is going to tell traffic manager to do is any traffic coming from this CIDR range will be able to hit this endpoint, which is Sydney endpoint. Any other requests coming from any other CIDR range, traffic manager is gonna ignore it. And of course, it's not going to work for me because I don't have a public IP address, but you should use it if you wanna have a different behavior of your employees in the company. They should get directed to a specific endpoint versus the external customers that for your company as well. This is one of the key things you want to use the subnet routing method for, is to help you sending the traffic to different endpoints based on their network CIDR range. And it can be very powerful in certain situations. That's all I have for you in this video. Now let's go ahead and clean things up. So I'm gonna go for resource groups and I'm gonna delete Sydney resource group. And as we already know, it's gonna delete all the resources we have in this resource group. That's all I have for you guys in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video we are going to talk about the multi-value traffic routing method, which allows you to get a multiple healthy endpoints in a single DNS response, which is going to allow you as a caller to do multiple client-side retries in case one of the endpoints was unavailable or unresponsive. And this pattern is going to be very helpful for you to increase the availability of your service and reduce the latency associated with creating a new DNS query. Now let's go ahead and create a traffic manager profile and see how can we configure it for a multi-value traffic routing method. So let's go ahead and create a new traffic manager. Let's call it multi-value test. And in the routing method here, I'm going to select multi-value and I'm going to create a new resource group. I'm gonna call it RG Sydney. And let's go ahead and create our traffic manager profile. Alright, now the traffic manager is created for me. So let's go ahead and browse to endpoints and let's go and add an endpoint. Let's try and click on the add button. As you can see here, multi-value routing methods cannot accept domain names or Azure endpoints or nested endpoints as a target. The only option that will work for us is to select external endpoint. And for example, we can type in google.com and here we need to specify FQDN or the IP address that we are after. So again, the main benefit of using the multi-value routing method is going to return multiple healthy endpoints in one DNS query. And this is going to provide more performance to the client so they can do multiple retries at their side without doing a new DNS query. That's all I have for you for the multi-value traffic routing method. Now let's go ahead and clean things up. Let's go to the resource groups. And let's select Sydney resource group. And let's go ahead and delete the resource group. That's all I have for this video. Thanks so much for watching, and I will see you in the next video. Hi everyone. In this section we are going to talk about traffic manager configurations. So we are going to see the different endpoint types that are available for you to use in traffic manager profile. Also how you can configure the monitoring for the different endpoints so you know the health status of your endpoints that you configure in traffic manager. Also we are going to see how you can configure an alias record for your traffic manager profile and how you get a real user measurements and see a traffic view coming to your traffic manager. This was just an introductory video about this section. Let's get straight into it, and I will see you in the next video. Hi everyone. In this video we are going to see how can we create an alias record for our traffic manager profile. And let's get started by creating two virtual machines. And we are going to install IIS on them. So let's create our first virtual machine. And let's create a new resource group for this. Let's call it RG Sydney. And I'm gonna call this VM01. And I'm going to put it in Australia East region. Then I'm going to choose Windows Server 2019. Then I'm going to specify my username and password for this VM. And I'm going to leave RDP port open. Then going to the networking and having a quick look at the new VNet and Subnet that are going to be created for me for this VM. And let's go all the way down and create our first virtual machine. Let's go ahead and create it. Now let's go to the second tab and create another virtual machine as well. I'm going to select RG Sydney resource group I just created before. The VM name is going to be VM02 and the server is going to be Windows Server 2019, and I'm going to specify my username and password for this VM. And I'm going to leave RDP port open and going to the networking, having a look and making sure that we are going to use the same VNet we have created in the first VM. And let's go all the way down to review our configuration and create our second VM. And let's go ahead and create our second VM. Now, getting back to our first virtual machine, now it's been ready for me, so let's go to the resource and do some configuration changes. The first thing we need to do here is to create a DNS name for our VM01. And I'm going to try to call it VM01-Traffic Manager, for example. And let's go ahead and save our changes. And let's get back to our VM01, going to the networking and allow inbound traffic on port 80. And let's go ahead and add this rule. Now let's open our Cloud Shell terminal, and we are going to run a command that is going to install IIS on this VM, VM01. Let's put our command here and let's do some changes. The resource group name here, I'm gonna write RG Sydney, and then the VM name, I'm going to type VM01. And let's go ahead and run this command. Now let's go to the other tab and do exactly the same thing on VM02. Let's specify a DNS name for VM02. I'm gonna type it VM02-Traffic Manager. And let's go ahead and save our changes. And let's go back to our VM02 and going to the networking and allow inbound traffic on port 80. And let's go ahead and add this rule. And let's open the Cloud Shell terminal and run the same command that is going to install IIS on VM02. Let's paste our command here. And for the resource group name, it's gonna be RG Sydney, and the VM name is going to be VM02. And let's run this command. Alright, now the IIS has been installed on VM02 as well as VM01. Now let's go and create our traffic manager profile. And let's go ahead and create a new traffic manager profile. I'm gonna call it Traffic Manager. And I'm going to choose Priority Routing Method, and I'm going to put it in Sydney Resource Group. And let's go ahead and create our Traffic Manager profile. And now let's go to our Traffic Manager profile and go to the endpoints. And let's add our endpoints. Let's select Azure endpoint, and let's call the first one VM01. And let's choose the resource type to be public IP address. And let's choose the public IP address with VM01 IP address. And let's give it priority 1. And let's go ahead and add this endpoint. And let's do the same and add another endpoint for VM02. And again, it's gonna be a public IP address for VM02 IP address. And let's select priority 2 for this endpoint. And let's go ahead and add it as well. Now we have added our endpoints to the Traffic Manager profile. So if we go to the Overview tab here and we copy the DNS name of our Traffic Manager, we should be able to get the result we are getting from VM1 because we have assigned the priority 1 to our first endpoint, which directed the traffic to VM01. Now let's go ahead and create a DNS zone. And this is where we are going to specify our alias record. So let's go ahead and create a new one. I'm gonna put it in Sydney Resource Group. And let's call it Traffic manager.com DNS zone. And let's go ahead and create our DNS zone. Alright, now let's go to our DNS zone and let's go ahead and add a record set. And let's call it Traffic Manager Record Set. And I'm gonna choose a record and I'm gonna specify an alias here, selecting my current subscription and the Azure resource I'm after. And in this case is going to be the Traffic Manager I have created. And let's go ahead and try to add an alias record for our Traffic Manager, but we will not be able to do it. The reason for this is when we created our endpoints in the Traffic Manager, we have selected Azure endpoints as the type of our endpoints. And this is not going to work for our DNS zone configuration. And in order to make it work, we need to specify an external endpoint instead of Azure endpoint. So I'm gonna go ahead and delete these two endpoints. And now I'm going to add two new endpoints, but for external endpoints. And I'm gonna call the first one VM01, and then I'm gonna put the public IP address for our VM01. And I'm gonna give it priority 1, and let's go ahead and add this endpoint. And let's do exactly the same. External endpoint, I'm gonna call it VM02, and then let's copy the public IP address of our VM02. And let's give it priority 2 as well. And let's go ahead and add our second endpoint. Now, let's go back to our DNS zone and let's try to do exactly the same, creating a new A record. And let's call it TM. And let's select an alias record for this. And now let's choose our Traffic Manager and let's go ahead and add the record set. The difference here is that we have created an external endpoint in our Traffic Manager endpoints instead of Azure endpoints for our VMs. And in this case, as you can see, we are able to create an A record for our Traffic Manager profile. And when you use the alias record you have created, you should be able to get directed to your Traffic Manager configuration. However, this is not going to work because I don't have a real domain name for this one. I was just showing you the different steps that you need to do to specify an alias record for your Traffic Manager profile. That's all I have for you in this video. Now let's go ahead and clean things up. Let's go to the resource groups. Let's close the Cloud Shell terminal. We don't need it anymore. Let's go for RG Sydney and let's go ahead and delete our resource group. And this is going to delete all resources we have created in our RG Sydney resource group. That's all I have for you in this video. Thanks for watching and I will see you in the next video. Hi everyone, in this video we are going to talk about the different endpoint types in Traffic Manager profile. And we have already seen some of them in previous videos, when we used the external endpoint to create an alias record for our Traffic Manager DNS name. And also I have used the Azure endpoints to link our endpoint into public IP address of a VM in different regions. So we are going to use this and deep dive into the different endpoint types in more details in this video. And the first thing we need to do now is to go ahead and create a new Traffic Manager profile. So let's go ahead and create a new one. Let's call it Traffic Manager. And let's select Priority Routing method. And I'm gonna put it in RG Sydney resource group. And let's go ahead and create our Traffic Manager profile. Alright, now my Traffic Manager profile has been created for me, so let's browse to endpoints. And let's add a new endpoint. And as you can see here at a high level, there are three endpoints available for me to add in the Traffic Manager profile. The first endpoint type we have is the Azure endpoint, which is used for services hosted in Azure, and we are going to see it in more details in a minute. Then we have external endpoints, which are used for IPv4 or IPv6 addresses, and these services could be hosted on-prem or in a different cloud hosting provider. And finally, we have nested endpoints, which you are going to use when you want to combine different traffic managers profile in different architectures. This will allow you to have more flexible traffic routing schemes to support you to build your architecture the way you want to build it. Now, let's get back to the Azure endpoint. And as you can see here, when it comes to the target resource types that are available in Azure, it's primarily focused on 4 categories. Cloud service, and this could be any PaaS service available in Azure. And also we have app service or app service slot, which we are going to see in more details in a minute. And finally, we have the public IP address, which we have seen already when we linked our endpoint to the public IP address of an Azure VM. Now, in order to be able to see the app service, we need to create few of them first. So let's go ahead and create few app service. Let's go ahead and create our first app service. And I'm going to put it in Sydney resource group. I'm going to call it Web App 01. And I'm going to select .NET version 6. And then I'm going to leave the service plan as a standard. Then going to monitoring, I'm going to disable the application insights. And let's go ahead and create my Web App 01 app service. And let's go to the other tab and create another web app as well. Let's use the same Sydney resource group and let's call it Web App 02. And then I'm going to select .NET 6 and again leaving the standard version 1, standard S1 for my app service plan. Going to monitoring and let's disable the application insights monitoring. And let's go ahead and create my Web App 02 app service. And finally here, let's go ahead and create the third app service again in Sydney region. And I'm gonna call it Web App 03. And I'm going to select the runtime stack to be .NET 6. And the region here, it's gonna be a little bit different. So I'm going to choose Australia East region and leaving the pricing plan standard S1. And I need to put my name in the web app name as well. Let's go to monitoring and let's disable the application insights. And let's go ahead and create my third web app. Now, let's go to the web apps or app services and see what we have created. As you can see here, we have created 2 web apps in Central US region. And the third one is still in progress in Australia East region. Now, let's get back to my Traffic Manager profile. And let's add an endpoint here and let's call it Web App 01, which is gonna be an app service. And I'm going to select Web App 01 that's hosted in Central US region. And I'm going to give it priority 1. And let's go ahead and add this endpoint. Now let's go ahead and add another endpoint and let's call it Web App 02, which is again gonna be an app service for Web App 02, which is again hosted in Central US region. And I'm going to give it priority 2. And let's go ahead and add the second endpoint. But we will not be able to do that. As you can see here, we have got an error. This is because Traffic Manager Profiles allows us to add only one endpoint that is directed to only one app service per region. That's why when we try to add another endpoint pointing to another app service in the same region, we have got an error. But if we try to add a new endpoint to an app service hosted in a different region, like Australia East, it should work. Now let's go ahead and add a name for this endpoint, web app 03, and I'm going to specify priority 3 for this, and let's go ahead and add it. And as you can see here, we have been able to add another app service because it's been hosted in a different region. And this is a restriction that you need to be aware of when it comes to adding an Azure endpoint. When it's using app service, you cannot be adding more than one app service if both of them are in the same region. However, this is as of end of November 2022. Maybe Microsoft is going to lift this restriction in future. So in case it does, don't assume that we have said something wrong. At the time of the recording, this is an actual restriction in the Traffic Manager profile. And Microsoft said it clearly in their documentation as well. Now I'm going to show you quickly how we can be adding an app service slot. So I'm going to go for the web app 1, and I'm going to create a new deployment slot for my web app 01. So let's add a new slot, and I'm gonna call it slot 01, and let's go ahead and add it to my web app 01. Alright, now my slot has been added for me. Let's get back to my Traffic Manager endpoints, and now I am going to add another endpoint type. However, I want to be able to do it because I have already a web app been added from Central US region. So I will need to delete web app 01 endpoint first. And now let's add another endpoint for the web app slot. And I'm gonna call it web app 01 slot. And for the resource type is gonna be app service slot. And I'm going to choose web app 01. And in this case here, I need to specify which slot I want the traffic to be directed to it. And now let's go ahead and create this endpoint. As you can see here, we have been able to add another endpoint for a slot. But again, let's try to create another endpoint for the main app, web app 01. And again, we want to be able to do it because the target has been already existing. Now, there is another restriction. So we now know that there is a little bit of restriction when we are using the app service for Azure endpoints. And the restriction is we cannot have more than one app service in each region. As a workaround for this, we can be using an external service. But before I will get to this, let's talk a little bit about the tier of the app service. So you remember when we created our app services, we have selected standard tier. And you should be able to see it when we go to the app service and then go to the app service plan. We should be able to see the tier is S1, standard 1. And this is another restriction that you need to be aware of when it comes to the app services in the Traffic Manager endpoints. I'm going to show you the link here to help you understand what I'm talking about. Only standard tier will be able to add as a traffic manager endpoint. And this is why we have been able to add these endpoints into our traffic manager, because these two endpoints are actually in standard tier. If we have been selected any other tier, basic tier, lower than the standard tier, we won't be able to add it at the first place in the traffic manager endpoints. And if we decided to change any of these tiers and downgrade it to basic, for example, instead of standard, then the traffic manager will stop sending traffic to this app service because it's not in a supported tier. So you need to be aware of that. Now, what will happen if we go back to our app service and we stopped it? Let's get back to our endpoints here and see how this would change our endpoints monitoring. As you can see here, the endpoint is still enabled because we hasn't changed anything from the traffic manager perspective. However, the monitoring CTS is able to see that the app service has been stopped. That's why the traffic manager is not going to send the traffic anymore to this endpoint or to this app service. Now, if I'm going to go back and start the app service, then the traffic manager should be able to pick it up. Now, remember when I said that there is a workaround we can do that will allow us to add more than one app service in each region in our traffic manager endpoints. And now let's go ahead and see how can we do that. Before that, I have just cleaned these two endpoints we have created before. And now let's go ahead and add a new endpoint, but this time we're going to choose an external endpoint. Let's call it web app 01. And let's put the fqdn, which is going to be the URL of our web app after removing HTTPS. And then we are going to specify priority 1 for this endpoint. Let's go ahead and add it. As you can see here, we have been able to add our endpoints, which is normal and expected. Now let's see what will happen if we added an external endpoint, and let's call it web app 2, which is again gonna be pointing to another app service hosted in the same region. And if you remember, we had been already some restrictions that didn't allow us to do this in the previous examples. And let's specify priority 2 and let's add this endpoint. And as you can see here, we have been able to add more than one app service hosted in the same region by using the external endpoint for the traffic manager endpoints. Now let's talk a little bit about the external endpoints, as I mentioned before. External endpoints allows us to use IPv4, IPv6 addresses that are hosted outside of Azure or could be hosted in Azure as well. And one of the main benefits of using the external endpoint is the increased redundancy that you are going to get of an existing on-prem data center, whether you are using active-active or active-passive failover mode in Azure. Also, this will allow you to route the traffic to endpoints that doesn't have DNS name associated with them. And this is also reduces the application latency for the users around the world. And by using the external endpoint, this will allow you to extend your existing on-prem applications or data center to different geographic locations around the world where Azure has data centers. And also this will allow you to have more capacity for an existing on-prem data centers. And this is used a lot in burst to cloud migration approach when you want to migrate your workloads from your on-prem servers to the cloud. So these are the different examples and scenarios when you should be consider using external endpoint. In addition to what we have seen before, when you want to create an alias record for the traffic manager DNS name, and when you want to add more than one app service per region as an endpoint for your traffic manager endpoints. Now, that's enough for the external endpoints. Now, let's go to the nested endpoints. And as I said before, you are using the nested endpoint when you wanna use nested traffic manager profiles. So when you wanna create a flexible traffic routing schemes that supports larger or complex deployments, having these nested endpoint will allow you to get a traffic from geographical traffic manager, for example, and push it to priority or performance traffic manager profile, and you can have as many nested traffic manager profiles as you want. That is going to support and help your architecture. And we are going to see the nested traffic manager in more details in the advanced section. That's all I have for you for this video. Now let's go ahead and clean things up. Let's go to our resource group. And let's select RG Sydney. And let's delete our resource group. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the endpoint monitoring in the traffic manager profile. So let's get started by creating a new traffic manager profile. Let's call it traffic manager monitoring. And let's select priority routing method, and let's create a new resource group. Let's call it RG Sydney. And let's go ahead and create our traffic manager profile. Alright, now the traffic manager has been created, so let's go ahead and browse to configuration. This is where we should be able to find the different endpoint monitoring for our traffic manager profile. And as you can see here, the first thing we have is the routing method that we have specified when we created our traffic manager profile. And according to our configuration, we have selected priority routing methods. And we have DNS time to live here, which has been set to 60 seconds by default. Now let's come to the endpoint monitoring settings. The first thing we have here is the protocol. You can choose either from HTTP, HTTPS, or TCP. Keep in mind that if you have selected HTTPS, Traffic Manager is not going to verify if the certificate is valid or not. It's just going to validate if the certificate is present or not. And if you are using other services like Azure Key Vault, you should be able to verify the validity of your certificate. Then you will get to specify the port that are you going to use for the request, monitoring requests. Then we have the path here. The path is valid only if you are going to use HTTP or HTTPS protocols. And if you specified it for TCP protocol, it's going to give you an error. Now moving to the custom header settings, you can add headers to the health checks that the traffic manager sends to the different endpoints. And there are two places you can add custom header settings. You can add a global header settings for the traffic manager profile. And in this case, it's going to be included in all endpoints, in all health checks for all endpoints in that traffic manager profile. And this is the right place to specify a global custom header settings for your traffic manager profile. However, if you want to add a specific header settings for a specific endpoint, you should be able to do that from adding a new endpoint and specifying the custom header settings that you want to add to a specific endpoint. So you have two ways to add your headers, either at the endpoint level and this is going to be applied in the health check of this particular endpoint only. Or you can add a custom header settings at the traffic manager profile level, and this is going to be a global settings which is going to be applied in all health checks sent to all endpoints specified in this traffic manager profile. And you can specify up to 8 headers. Using asterisks is not supported in the custom header settings. This value is not supported, as you can see here. Now, moving to the expected status code ranges. By default, Traffic Manager expects the response code to be 200. However, you are able to specify different code ranges. For example, I could specify from 200 to 299. And for all response codes that's been received from my endpoint within these ranges, the Traffic Manager profile is going to expect or assume that the endpoint is healthy. So according to the response codes I specify in here, then the Traffic Manager is going to assume that the endpoint is healthy. And I can specify different ranges as well, as you can see here. And if I didn't specify anything at all, then the Traffic Manager is going to be looking up for response code 200. If 201 has been returned, then the Traffic Manager is going to assume that the endpoint is unhealthy. Now coming to the probing interval. By default, it's 30 seconds. And this is called the normal probing. And in case if you want to have a fast probing, you can speed it up to 10 seconds. However, it's gonna add more cost for you if you are gonna go for the fast probing. Now, moving to the tolerated number of failures. It can be any value from 0 to 9. And if you specify the tolerated number of failures as 0, then the Traffic Manager is going to define an endpoint as unhealthy if it didn't return the expected status code ranges. So by default, the value is specified to be 3, however you can specify it up to 9. And for the probe timeout here is the amount of time that the Traffic Manager probing agent should wait before declaring an endpoint as failure. And keep in mind that the probe timeout is a little bit linked to the probing interval. For example, when we specify a probing interval to be 30 seconds, then the probe timeout should be from 5 to 10 seconds. If I try to make it 15, it won't work. As you can see here, I get this error message that says the value must be between 5 to 10. But when I change the probing interval to be fast probing, the probe timeout value will be different. It should be any value between 5 to 9. So make sure that you are going to select the right timeouts that will work for your situation. So this kind of the general configuration you could specify for your Traffic Manager profile to configure the endpoint monitoring for different endpoints in your Traffic Manager profile. Now let's understand how the endpoint monitoring works. So let's assume that we have configured our Traffic Manager profile to use either HTTP or HTTPS as the protocol, as the monitoring protocol for our endpoints. So what's going to happen is that the Traffic Manager is going to send GET requests to the different endpoints that are defined in our Traffic Manager profile. And they are going to send it using the right protocol, whether HTTP or HTTPS, on the specified ports, using the relative path and the custom headers, if any of them had been specified in the configuration. Then the Traffic Manager is going to consider this endpoint as healthy if the response code was 200, which is the default, or any of the response codes we have specified in the expected status code ranges, if you remember here. So if we specify 200 to 400 here, then the traffic manager receives the 305, then the traffic manager still will consider this endpoint as healthy. Now, if a different response code has been returned, or no response code has been received within the timeout period, then the traffic manager probing agent is gonna reattempt according to the tolerated number of failure settings. If we specified it at 3, then the traffic manager probing agent is gonna try 3 more times before declaring this endpoint as unhealthy. However, if we specified our tolerated number of failures as 0, then the traffic manager is going to declare this endpoint as unhealthy after 1 failure response from the endpoint. So this is what's gonna happen when we set the traffic manager to use the monitoring protocol to be HTTP or HTTPS. So what's gonna happen now when the monitoring protocol is TCP? So now the traffic manager probing agent is gonna create TCP connection request using the port we specified in our configuration. And if the connection has been established, then the traffic manager is going to declare this endpoint as healthy. And if the traffic manager received a different response code than what we have specified in the expected status code ranges, or didn't receive a response at all within the timeout period we have specified in our configuration, then the traffic manager probing agent is going to reattempt according to the number we have specified in the tolerated number of failures. And then after that, the traffic manager is going to declare this endpoint as unhealthy. When the number of consecutive failures is higher than the tolerated number of failures we have set in our traffic manager profile, then the traffic manager is going to declare this endpoint as unhealthy. Now let's look at this graph in more details. So when the traffic manager sends a GET request to the endpoint, again, it's gonna send it according to the specified protocol, port, headers, as we have configured it. If the endpoint returned 200 OK, then the traffic manager probing agent is gonna assume this endpoint as healthy. And then the traffic manager is gonna apply the reattempting or revalidating of the endpoint health status every 30 seconds interval, which what we have specified here in our probing interval. So after 30 seconds, the traffic manager probing agent is going to send one more request, and if the endpoint responded with 200 OK, then the traffic manager is going to declare this endpoint as healthy. Until the time comes when the traffic manager probing agent sent a GET request, again on the specified protocol, port, header number. And for some reason, the traffic manager didn't get a response back from the endpoint, or the response came outside of the timeout period we have configured before. At that point, the traffic manager is gonna assume this is the first failure. After that, the traffic manager is going to try 3 more times, as we have configured here, tolerated number of failures. And when we specify it as 3 here as a default value, then the traffic manager is gonna reattempt the request 3 more times after the first failure. So it's gonna be 4 attempts in all. At that point, the traffic manager is going to divert the traffic to other endpoints to make sure that the traffic is gonna be served. And while this happens, the traffic manager is going to continue check the health status of the original endpoint every 30 seconds. And when it comes back online and responding with 200 OK for a particular GET request, then the traffic manager is going to declare this endpoint as healthy again. Then if we have configured priority routing method for our traffic manager profile, then the traffic manager should be directing the traffic again to the original endpoint that was unavailable for some reason in this timeline. So this is how the traffic manager works to understand the health of the different endpoints defined in the traffic manager profile, and how the traffic manager fails over to other endpoints if the primary endpoint wasn't available for any reason. Now let's get back to traffic manager profile on Azure here, and I want to show you the different status. So we have traffic manager profile status, where you can enable or disable it. And also, if you remember, we also have endpoint status, where we can enable it or disable it. Now I'm gonna go ahead and create a new app service and add it as an endpoint to our traffic manager to just help you understand what we mean by the endpoint status. Now let's select Sydney Resource Group. Let's call this web app. And let's select .NET 6. And let's host it in Central US. Go into the monitoring and let's disable application insights. And let's go ahead and create this web app. Alright, now my web app has been created, so let's go back to my traffic manager and add the web app as an Azure endpoint. Let's call it web app. Let's select app service and let's select my app service. And let's go ahead and add it. So this is to show you what is the difference between the profile status and the endpoint status. Sometimes the profile can be enabled, but the endpoint could be disabled, which means that the traffic manager is not going to send the traffic to this particular endpoint anymore. And to help you understand how the traffic manager status works in conjunction with the endpoint status. So let's have a look at this table, which is provided in the Azure documentation. As I said before, we have two status, endpoint status, and we have traffic manager status. So when we disable the traffic manager status, the global one, it's going to make all endpoints inactive because we have stopped the traffic manager at the global level. And this is gonna impact all endpoints we have specified in our traffic manager profile, even though leaving the endpoint status as available or as enabled, it's gonna make the endpoint monitoring status as inactive because the global profile status is disabled. When the endpoint status is disabled, so when we go to a particular endpoint here and we disable it, so what's gonna happen in this case, that the endpoint monitoring status is gonna be disabled because the traffic manager is not going to send any requests, and hence not any monitoring is going to be sent to that particular endpoint because it's been disabled. Now, when we have the profile status is enabled and the endpoint status is enabled, this is the happy scenario. The endpoint monitor status is going to be online. This is the perfect scenario for us. And also, when we have our profile status as enabled and the endpoint status as enabled, but the endpoint monitoring status degraded, this happens when the traffic manager probing agent is not able to get a response back from the endpoint, even though the endpoint might be enabled. but for some reason the traffic manager probing agent didn't get a response back, then it's gonna specify the monitoring status as degraded. And when we have both the profile status and the endpoint status as enabled, and we still have the monitoring status checking endpoint, this happens when you create or add a new endpoint to your traffic manager. Initially, the traffic manager wants to ensure or getting the status of this endpoint, and during this time, you will be able to see the monitoring status as a checking endpoint because the traffic manager still tries to initialize the status for this particular endpoint. Finally here, when the profile status as enabled and the endpoint status as enabled, but you have stopped the backend service as we have done it before, when we stopped our app service, then the endpoint monitor status is gonna be stopped. And it's gonna be resumed when you start the endpoint again. So I'm going to leave a link for this table in the description box. This is very important to help you understand what are the different status between profile, endpoint, monitoring status for the traffic manager profile. And in case if you are wondering what's going to happen when the traffic manager declares a specific endpoint as unhealthy and how this would affect the routing method we have created when we created our traffic manager profile. This will help you understand how the traffic manager is going to react based on the routing method. For example, when you are using a priority routing method, then the first available endpoint will be used to send the traffic if the primary endpoint was degraded. And if you are going to use weighted routing method, then the traffic is going to be distributed to other available endpoints according to the assigned weights you have specified on them. And if you have used the performance routing method, then the traffic manager is going to send the traffic to the closest Azure region. Doesn't have to be closest from the geographical perspective, but it means closest from the network latency perspective. So for the geographic routing method, this one is a bit tricky. You remember in the geographic routing method, geographic location can be mapped only to one endpoint in a profile. So if the endpoint is not available, then the traffic wants to be directed to other regions or fail over to other regions. So as a best practice, when you want to use geographic routing method, consider combining it with other traffic manager profiles and using the nested traffic manager profiles to allow you to fail over from this routing method. And then we have the multi-value routing method and the subnet routing method. Now there is one more thing I want you to keep in mind. When the traffic manager initiates this endpoint monitoring or health check, it initiates it from different locations around the world. This is to make sure or to give a most accurate version of the health check. Because if the traffic manager initiates the health check from one Azure region, it won't necessarily give an accurate health check condition of a specific endpoint. That's why the traffic manager uses different algorithms and different Azure data center or regions to send the health checks for different endpoints. And based on the results, there is a bit of calculation that the traffic manager uses, and based on the average value, the traffic manager is going to specify an endpoint as unhealthy or unhealthy. So that's all I want to talk about for the endpoint monitoring when it comes to the traffic manager endpoint monitoring. Now let's go ahead and clean things up. So let's go to the resource groups and let's select RG Sydney and let's go ahead and delete our resource group. That's all I have for you in this video. Thanks for watching and I will see you in the next video. Hi everyone. In this video we are going to talk about the real user measurements in Traffic Manager profile. And this will only work if you configured your Traffic Manager to use performance routing method. And we already know from previous videos, when you configure your Traffic Manager profile to use performance routing method, Traffic Manager is going to route the traffic to the Azure region that will have the lowest latency to the client. Doesn't necessarily mean that the Traffic Manager is going to route the traffic to the closest Azure region from the geographic perspective. I hope that is clear for you. So the real user measurements will allow you to measure the network latency to different Azure regions from the client application. So Traffic Manager is going to consider this information while making the routing decisions to different Azure regions. And this is going to increase the accuracy of the routing for your requests. Now let's go to the Azure portal and see how can we enable the real user measurements. Let's go ahead and create a new Traffic Manager profile. And let's call it Traffic Manager Real. And then let's select Performance Routing Method. And let's create a new resource group. Let's call it RG Sydney. And let's go ahead and create it. And let's create our Traffic Manager profile. Alright, now let's go to our Traffic Manager and let's browse to real user measurements. And as you can see here, the first thing I need to do is to generate a key that I'm going to use in my application. So after we generate our key, there are two ways we can use to send the real user measurements to Traffic Manager. The first way is by using Visual Studio. And as you can see, currently it's supported only for Android. So as you can see here, we need to generate the key, and after that we need to include this data into your Visual Studio and use these two imports there that will allow you to send your real user measurements to your Traffic Manager profile. And the other way we can use is to include some JavaScript file into your web pages directly. Again, you need to generate a key, and after that you need to include this JavaScript file into your web page, and then it's going to send the real user measurements to Traffic Manager. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the traffic view in Traffic Manager profile. And let's go ahead and enable it. So let's browse to my Traffic Manager profile, and let's browse to Traffic View. And then let's go ahead and enable Traffic View. It's supposed to show here a world map that shows to you where the traffic is originating from and which endpoints the traffic is getting directed to. And also you will be able to see this information in the table below. However, because my Traffic Manager is pretty new and I don't have much traffic yet been through my Traffic Manager, we won't be able to see much information. So I'm going to get this view from Azure documentation to help you understand how traffic view is going to look like. As I said before, it's going to be a world map. Shows you where the traffic is originating from, which endpoints the traffic is going to be directed to. And in the table below, you will be able to see more detailed information. For example, you'll be able to see the IP address. And of course, this is not going to be the IP address of the end user. This is going to be the IP address of the local DNS resolver for the user. And then you will be able to see which endpoint the traffic has been directed to, and in which location or Azure region, and how much volume or requests has been received through this endpoint. And more importantly and finally, you will be able to get a sense of the latency that the end user experienced when they sent their request to a specific endpoint. Maybe you can need to do a different routing algorithms or using a different routing method to decrease the latency that the end user is experiencing when using your endpoints. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this section, we are going to talk about the advanced topics in Traffic Manager Profile. First of all, we are going to see Traffic Manager nested profiles, which will allow us to combine multiple Traffic Manager profiles in one architecture to solve certain problems. Then we are going to move on to look at how we can combine multiple load balancing services in one architecture to solve certain problems. And finally, we will get to talk about the disaster recovery and how we can use Traffic Manager in our disaster recovery implementation. This is just an introductory video for the advanced section. Let's get straight into it, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the nested Traffic Manager profiles. And as you are here on the portal, let's go ahead and create some Traffic Manager profiles. So let's go ahead and create the first one, and I'm gonna call it Parent Traffic Manager. And I'm gonna choose Performance Routing Method, and I'm going to host it in Sydney Resource Group. And let's go ahead and create our first Traffic Manager profile. And now let's go ahead and create the second profile, and let's call it a Child Traffic Manager. And let's use weighted routing method for the child profile. And let's put it in Sydney Resource Group. And let's go ahead and create our child profile. Alright, now I have the two Traffic Manager profiles been created for me. So I'm gonna go and browse for the Parent Traffic Manager, and I'm gonna go to the endpoints. And let's go ahead and add a new endpoint. When we get to the endpoint type here, you remember in the Endpoint Types video, we discussed that there are different endpoint types you can use and associate to your Traffic Manager profile. So now I'm going to choose the nested endpoint, which will allow me to add another Traffic Manager profile as the target resource for this endpoint. So let's call this endpoint first nested endpoint. And then for the target resource, I'm going to select Child Traffic Manager profile. And for the location, I'm gonna select Australia East region. And we have here a parameter, minimum child endpoints, which we are going to talk about it in more details later. Now let's go ahead and add this endpoint. Now let's get back to our endpoint. And there are a few parameters here I want to talk about. The first one is the minimum child endpoint. And this is the minimum number of healthy child endpoints that are required for the nested profile to be marked as healthy. And also we have two other parameters, minimum IPv4 child endpoints and minimum IPv6 child endpoints, which is the minimum number of healthy endpoints so the nested profile can be marked as healthy. But this is specific for IPv4 and IPv6, and we are going to see a use case for these two parameters in more details later. So these are the different parameters, and now let's go to Azure documentation and see the different use cases we can use for the nested Traffic Manager profiles. And the first use case we are going to see here is using performance routing method with weighted routing method in one architecture. Let's talk a little bit about what are we trying to achieve here. Let's assume that we have a global system that's deployed in multiple regions: Western US, Western Europe, and Eastern Asia. And we want to allow a production testing on a small portion of users before we roll out our changes to other instances. So this is our target. So as a parent profile, we are going to be using performance routing method. So the traffic manager or the parent traffic manager is going to route the traffic to the closest Azure region. And when I say closest, you all know that I mean closest from network latency perspective, not from a geographic perspective. And this is going to be our parent profile. Then we are going to add 2 endpoints for the other Azure regions, Western US and Eastern Asia. Then we are going to add a child traffic manager profile on Western Europe region. And we are going to configure it to have 2 endpoints. And as you remember, we said that we are going to use weighted routing method. So we are going to configure our child profile to route 99% of the traffic to the production endpoint and route 1% of the traffic only to the trial endpoint to test the update on a smaller portion of users before we roll it out to the wider users. So this is an example that shows how we can use performance routing method with weighted routing method in one architecture to allow us to test our changes on a smaller portion of users before we roll it out to all users in our system. Now moving to the second scenario or second example, which will allow us to see how can we do endpoint monitoring in the nested profile. From previous videos, you must already know that the traffic manager continuously monitors the health status of the different endpoints configured in the traffic manager. This will allow the traffic manager to know the health status of different endpoints and whether to route traffic to them or not based on their status. But when it comes to nested profile, it's not gonna be the same. Like the parent profile is not going to be checking the health status of the child profile. Because if this is the case, then the parent profile will always see that the child profile is healthy because it's an Azure service, highly available, etc. So what's gonna happen in the nested profile case is that the child profile endpoints are going to be used to calculate the overall health status of the child profile. And this information is gonna be propagated up to the parent profile to help the parent profile to make the right decision and to be aware of the health status of the nested traffic manager profiles that are attached or linked to the parent profile. So in case we have lost the production endpoint in Western Europe region, but we still have the trial endpoint. So the minimum child endpoint in this case for our child profile is gonna be equals 1. And this will allow the parent profile to be able to see that our child profile is still healthy. And the parent profile will still be directing traffic to the child profile, which is gonna be sent to the trial endpoint. But someone might say, we actually do wanna do that. If we lost the production endpoint, we don't wanna send all the traffic to the trial endpoint because we haven't tested it yet. And I completely agree with you. So what we can do in this situation, if we lost the production endpoint and we want the traffic manager to not send the traffic to the trial endpoint, is simply by changing the minimum child endpoint value in the child profile and set it to 2. So in this case, when the number of healthy instances in the child profile is less than 2, then the parent profile is going to consider the child profile as unhealthy, and it's going to neglect it altogether and send the traffic to other regions, Western US and Eastern Asia, even though the trial endpoint is still up and running and healthy, but we have configured our child profile to be marked as healthy when it has 2 endpoints healthy as a minimum. If one endpoint is only healthy, then the child profile is gonna be marked as unhealthy. And then the parent profile is going to ignore it and not sending any traffic to it until the production endpoint becomes available again. The other example we want to talk about here is periodize the failover to other regions. Again, we have our parent profile been configured to use performance routing method, and we have our child profile has been set to a priority routing method. And we have configured it to be a priority for a reason, because when a failure happens in Western Europe region, we want it to fail over to Western US region. So in this case, we have added our child profile and set it to priority routing method. And we added two endpoints for our child profile. Our first endpoint is going to be our Western Europe, and we are gonna set priority 1 to it, which means that Western Europe region is going to accept or take 100% of the traffic coming from the child profile. Then we are going to configure a second endpoint, which is West US endpoint, and we are going to give it priority 2. So as long as Western Europe region is up and running, Western US region will not accept any traffic, because we have set priority 1 to Western Europe region, which means it's gonna take 100% of the traffic all the time until a failure happens to Western Europe region. Then child profile is going to send the traffic, 100% of the traffic, to the Western US region, because this is the failover plan we have configured our child profile to do in case of any failure happens in our primary region. Having said that, parent profile is still able to send the traffic to all three endpoints at the same time. Like there are gonna be two traffics landed to US region. One of them directed from the parent profile, and the other one directed from parent profile through to child profile through to Western US region in case there is a failure happened in the Western Europe region. This is how can we configure a periodized failover using nested traffic manager profiles. Now the next example we're going to talk about is using performance routing methods in the same region. So we already know that when we use a performance routing method and our endpoints are separated across different regions, then the traffic manager is going to send the traffic to the endpoint that has the lowest network latency. However, if all of these endpoints are in the same region, then the traffic manager, and we set our traffic manager to use performance routing method, then the traffic manager is going to distribute the traffic evenly across all of these endpoints in the same region. And if we look at this graph here, we will be able to see this. So this is our traffic manager, and we have Western US region and another endpoint for Western Europe, another endpoint for Western Europe, and then Eastern Asia region. So for these two endpoints in Western Europe, the traffic manager is going to distribute the traffic evenly across these two endpoints. Now, what if we want to have more control about how we can distribute the traffic to different endpoints in the same region? And what we can do in this case is to add a child profile and set it to use weighted routing method. Then we are going to add two endpoints in Western Europe region. And we are going to set one endpoint to have weight, let's say 99, and the other endpoint to have a weight of 1, so we can have more control how we can send the traffic to different endpoints in the same region. And definitely we can play around with these weight values we specify in different endpoints. Now the other use case I want to talk about is using the nested profile for endpoint monitoring. We already know that the traffic manager is doing endpoint monitoring by specifying the monitoring settings in the traffic manager profile. And these settings is going to be applied to all endpoints been attached or configured in this traffic manager profile. It's going to be completely okay if all of our endpoints are on the cloud, because they are going to use the same monitoring settings. But what if we have another endpoint for an on-prem server? Definitely it won't take the same monitoring settings as other Azure endpoints would take. So in this case, we could be adding a child profile, and we configure its monitoring settings to be applicable to the applications been hosted on-prem. So monitoring settings are not gonna be inherited from the parent profile. So our parent profile has monitoring settings set to monitor.aspx, and this is gonna be used to test the health status of the Azure endpoints. And then our child profile has a monitoring status set to \, and this is gonna be used to test the health status of the on-prem application. This is how we can use the nested traffic manager profile to determine the health status of different applications hosted in different data centers, on-prem and Azure, etc. And the last example I want to talk about here is using the nested profile to determine the health status of IPv4 or IPv6. And you remember these were parameters we have found in our parent profile. So in this example, we have our parent profile, and we have two child profiles in Eastern US and Western US, and we have configured them to have minimum number of healthy childs to be 2, and minimum number of healthy child for IPv4 to be 1, and the minimum number of the healthy child for IPv6 is gonna be 1. So in case we have lost 2 endpoints that are running IPv4, and we have configured that the minimum number of healthy child that has IPv4 should be 1, then in this case, the child profile doesn't meet the health criteria we have configured. Then the parent profile is going to consider the Eastern US profile as unhealthy because it lost some IPv4 endpoints, and we have configured our child profile to has as a minimum 1 healthy IPv4 endpoint to mark this child profile as healthy. And in this case, the parent profile is going to route the traffic to Western US profile because it has the health criteria we have configured. So these are different scenarios, use cases, or examples where you can use or combine different traffic managers profile to use them for different purposes. Now let's go back and clean things up. So let's go to traffic manager, and I'm gonna delete these two traffic managers because I'm not gonna use them anymore. Let's delete the child profile as well. Great. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video we are going to see how can we combine multiple load balancing services into one architecture. As you're already aware of, this course is primarily focused on Traffic Manager, and previously I've done separate courses for application gateways and for Azure Front Door, and I have a plan to cover Azure Load Balancer in future. So these are the 4 load balancing services that are available in Azure. And if you think you would be able to use only one of the load balancing services in a complex architecture, you will be wrong. In most complex architecture, you will need to use multiple load balancing services at different layers to allow you to reach your targets. And in this video, we are going to see how can we combine some of these load balancing services in one architecture. So let's have a look at this page at Microsoft documentation here, and there is a scenario that we are going to cover in more details. The scenario simply has a website that has 2 content, static content which are images, and dynamic content as well. There are some requirements for this website. The website must be geo-redundant, and it should be able to serve user from the closest location. And you already know when I say closest location, we mean the lowest latency from networking perspective, not from a geographic perspective. Then we want to do some URL-based routing on the incoming requests. And whenever we see images in the incoming URL, we are going to direct it to a dedicated pool for the static content. And finally, we want to have the dynamic content to send the traffic to a database cluster at the backend. So these are the different things we need to do in our architecture. And if we are gonna break it down here, we will be able to see that first requirement is we want to have a geo-redundancy. We want to be able to host our solution or our website in multiple regions. And second requirement we have here is the ability to be able to send the user requests to the closest Azure region, closest from network latency perspective again. Third requirement we have here is independent scalability. As I mentioned before, we have a static content, which is represented in images, and we have dynamic contents as well. And we want to be able to scale our website independently. Each of these tiers should be able to scale independently. And finally, here we want to do load balancing for the traffic going through our database cluster. So this is the challenge that we want to solve, and we want to use different Azure load balancing services to address all of these problems in different areas. And the first thing I want you to look at is this comparison table between different Azure load balancing services across two dimensions. First dimension is the geography, whether it's a global or regional coverage. And the second dimension about the traffic, whether it supports HTTP, HTTPS, or non-HTTP traffic. So let's get back to our scenario. Our first requirement here is to have a geo-redundancy for our website, which means we want to allow our website to be deployed in multiple Azure regions. And of course, we want to be able to send the traffic to the closest region so we can cover the second requirement as well. In order to achieve geo-redundancy, we need to use Azure Load Balancing Service that doesn't set in one region. So the Azure Load Balancing Service we are going to use has to be a global service. So it will be able to distribute traffic across multiple regions. And if we get back to our table here, we will be able to see that there are two global load balancing services we can use: Traffic Manager and Azure Front Door. And we already know that Azure Front Door operates at layer 7, while Traffic Manager is a non-HTTP traffic. And in this scenario, we cannot use the application gateways or the load balancer to distribute traffic across regions. And the reason for this, because both of these services are regional based. They have to be hosted and operated in one region. So let's take this information and get back to our scenario. We will see that Traffic Manager will be the best fit to use in this scenario. So we will be able to distribute the traffic across two Azure regions, which will achieve the geo-redundancy for our website. And this is the first requirement we had here in our scenario. And for the second requirement here, we will be able to achieve it by using performance routing method for our Traffic Manager profile, which is going to ensure that the Traffic Manager is going to send the user requests to the closest Azure region, which is going to provide the lowest latency to the user requests. And this would be our second requirement for this scenario. Now moving on to the third requirement, which is independent scalability. And also I want to link it to the two types of contents that we have in our website, the static content and dynamic content. We want to build some URL or path-based routing in the incoming requests. And whenever we see images in the URL, we want to route the traffic to a dedicated pool that's specified for static content, which are our images. If you remember from the Application Gateways course, you will know that we can use Application Gateway to perform path-based routing on the incoming requests. And based on that, we can configure the Application Gateway to send the traffic that has images in the URL to a dedicated pool. And in this case, we are going to call it Image Server Pool. And then we are going to configure the Application Gateway to send any other requests to the default server pool, which is a pool dedicated for the dynamic content for our website. So by using the Application Gateways here, and specifically the URL or path-based routing, it will allow us to direct the traffic to different backend pools based on certain information that we are receiving in the incoming URL. So by doing this, we will be able to send the user requests that has images in the URL path to the images server pool, which is going to be our static pool. And then all other requests are going to be sent to the default server pool, which are designed to handle the dynamic content of our website. Now, as we have separated these two pools into different backend pools, the static content in one pool and the dynamic content in one other pool, then we will be able to scale each of these pools independently. In case when we're getting so many requests on the dynamic backend pool, we will be able to scale it up and have more VMs running on this backend pool. And whenever we get more requests hitting the static backend pool, we should be able to scale it up as we need. This will address the third requirement we had here, which to allow our website to scale independently. Now, coming to the last one, how we are going to send the traffic from the dynamic content, which is the default server pool, into our database cluster. And in this case, we will be using a load balancer service. So our dynamic content pool are going to send the traffic to a load balancer. And then the load balancer is going to distribute the traffic to different database tiers in a database cluster. So in case one of the database nodes becomes unavailable for any reason, the load balancer will stop sending traffic to the unhealthy database node. And then the load balancer will continue sending the traffic to the healthy database nodes in our database cluster. And someone might say, why we have used the Application Gateway here instead of the Azure front door? And it's a very valid question. Application Gateway here operates at layer 7, similar to the front door. But when we get back to our table, we will be able to see the difference. And yes, you are right, both of these load balancing service supports HTTP traffic, but there is other difference. Application Gateway operates at a regional level compared to the Azure front door, which operates globally. And this is why we have used Application Gateway here in each region separately, because it's a regional service which will allow us to have an Application Gateway in each region we host our application. Now, someone might be asking why we haven't used Azure front door instead of the Application Gateway. Yes, we know it's a global service. It's gonna sit globally here below the traffic manager outside of these two regions. But what would be the harm of doing this instead of managing two instances of application gateways in two different regions? And the simple answer for this, it's gonna add more complexity to your architecture, and it's going to make it difficult to traffic manager to do the performance routing method. because the endpoint of your traffic manager profile would be the Azure front door, which sits globally across multiple regions. Then the traffic manager wouldn't know which region the traffic manager should send the user requests to it to achieve the lowest latency to the user. So even though Azure Front Door supports the same traffic protocol as the application gateway, we will not be able to use it in this scenario because it will not help us to solve our problem. So this is the architecture of the scenario, and if you scroll a little bit down, you will be able to see a step-by-step guide on how you are going to implement this solution in Azure. However, I'm not going to build it myself, but I strongly recommend you to walk through it to get more familiar with different Azure load balancing services. Again, the main purpose of this video is to get you familiar with different Azure load balancing services and combine them in one solution, because it's very rare when you find yourself using only one load balancing service in an architecture. And if this is the case, there is nothing wrong with that. But I wanted to empower you with the knowledge that will allow you to use multiple load balancing services in one architecture if you needed to. And as always, feel free to get back to this comparison table whenever you are in doubt. This is going to help you answer most of the questions about what would be the right load balancing service for me. So by keeping in mind these two main dimensions, the geographic dimension, whether the service should be covered globally or regionally, and the traffic dimension, whether it supports HTTP or non-HTTP traffic. I think that's all I have for you in this video. Again, feel free to go through this demo here and implement it yourself to get more familiar with different Azure load balancing services. And also feel free to check my other courses about the application gateways and front door, and hopefully in the near future, Azure Load Balancer. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about the disaster recovery using Azure Traffic Manager. And I'm assuming that you are familiar with different disaster recovery concepts, like active passive, cold standby, warm standby, and pilot light. If you are not familiar with these concepts, I'd suggest you go ahead and have a read on the page that I'm going to put a link for it in the description box. Now we are going to talk about how we are going to be using Traffic Manager to do automatic failover between two sites, primary site and the backup site. It could be in two Azure regions, or it could be in one Azure region and your on-prem data center. So in this diagram here, we see that we have an active region and a passive region. And the active region, we are using the application gateway, some application servers, and we have storage and SQL Server. We are not going to dive too much into the details of the deployment here, because our target is up there in the Traffic Manager. So we are going to create Traffic Manager and use priority routing method. So we are going to create priority 1 and assign it to the active endpoint, which is going to instruct the Traffic Manager to send 100% of the traffic to the active region. At the same time, we have our passive region, exactly the same setup we have in our active region. We have application gateway and virtual machines to run our app server, and we have some storage and SQL Server. And we are going to specify priority 2 for the passive region. So in case the health checks detected unhealthy status from the active endpoint, then the Traffic Manager automatically is going to route the traffic to the second highest priority in the endpoint configurations. And in this case, it's going to be the passive region. And whenever Traffic Manager health checks started to detect a healthy status from the active region, then the Traffic Manager is going to stop sending the traffic to the passive region and sending 100% of the traffic again to the active endpoint or active region. So this is briefly how can we use Traffic Manager to route the traffic automatically between the primary region and the failover region. And if you scroll a little bit down, you should be able to see a step-by-step guide that will walk you through how you can create automatic failover using Azure Traffic Manager. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about blue-green deployments using Azure Traffic Manager. And in case if you don't know what blue-green deployment is, it's simply a software rollout method for new releases, aiming to reduce the impact or interruption to the end user. So the blue part is going to be the current production release that's serving the user traffic. However, the green part is going to be the new release that we want to deploy. Until that point, probably you could have guessed how can we use Traffic Manager to achieve blue-green deployments. And as you can see here, we will be using weighted routing method for our Traffic Manager profile. And we are going to have two endpoints. The blue endpoint, which is the current production release, and we are going to assign 1000 weight to this endpoint. At the same time, we are going to have the green deployment, which has the new software release, and we are going to assign weight 1 to the green endpoint. This will allow us to test the new release, the green deployment, on a smaller portion of users. So in case any error happened or any interruption happened to the green deployment, it won't impact the wider users. This is the whole point of blue-green deployments. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this section, we are going to talk about Traffic Manager monitoring. And we are going to see how can we configure diagnostic settings for our Traffic Manager profile. And we are going to see the key metrics and how we can set up some alerts on these metrics. And finally, we are going to see the different logs that will be available for us in Log Analytics workspace. Let's get straight into it, and I'll see you in the next video. Hi everyone. In this video, we are going to see how can we configure diagnostic settings for our Traffic Manager profile. So let's browse to my Traffic Manager, and then let's go to Diagnostic Settings. And as you can see here, I don't have any diagnostic settings defined for my Traffic Manager profile, which is not a good idea. So let's go ahead and create a new diagnostic settings. Let's specify a name for it, my diagnostic settings. And then as a good practice, you should aim to get all logs and all metrics being pushed out to your destination resource. And in the destination resource here, you have an option to choose from either Log Analytics workspace or a storage account or Event Hub or a partner solution. So I'm going to choose sending the logs and metrics to a Log Analytics workspace. I'm going to go with my default Log Analytics workspace. And then let's go ahead and save my changes. And as you can see here, now we have configured diagnostic settings for my Traffic Manager profile to sending all the logs and metrics to the Log Analytics workspace. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about Traffic Manager metrics. So let's browse to our Traffic Manager and let's go to metrics. And the good news is Traffic Manager has only 2 metrics, but they are really key and important to understand them well. The first metric we have is endpoint status by endpoint. And by selecting this metric and changing the aggregation to average, this metric should show us 1 or 0, black or white. Of course, we don't see any information here because I haven't configured any endpoint for my Traffic Manager as I'm recording this video. So this metric should be either 1 if the endpoint is up or 0 if the endpoint is down. And if you have two endpoints, for example, one is up and one is down, then this metric should be 0.5 because it calculates the average endpoint status that you have configured in your Traffic Manager profile. And the other metric we have is the number of queries by endpoint results. So this is going to show you how many times Traffic Manager returned queries related to a specific endpoint. And if we're gonna go ahead with this metric, we can add a filter where you can select an endpoint name and ask Traffic Manager to filter the result or the graph based on a specific endpoint name to get more clarity or more granularity about this endpoint. These two metrics are really important, and it will help you to get more understanding about your Traffic Manager profile. It's gonna be even better if you set up some alerts, like what we are going to see in the next video, to notify you of any abnormalities you might expect in your Traffic Manager profile. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about the alerts in Traffic Manager profile. So let's browse to our Traffic Manager and let's go to alerts. And let's go ahead and create a new alert. And let's choose one of the metrics that we have talked about in the previous video. So I'm going to choose endpoint status by endpoint. I'm going to set the threshold as a static, and I'm going to select average aggregation type. I'm going to set it if it's less than 1. And I'm not going to add any split by specific endpoint names or anything. I'm going to leave the check every 5 minutes and lookback period to be 24 hours. And of course, I can add a specific condition if I want to. Then moving to the actions, I can either select from an existing action group or create a new action group. I'm not going to create any at the moment. Let's go to the details, and then I'm going to specify the severity level of this alert to be critical, and then the alert rule name is going to be endpoint status is less than 50% or something. I need to get rid of the percentage. Now going to the tags, and then let's go all the way down to create our alert. This is what you need to do to create an alert for your Traffic Manager profile. And when we create an alert, we create it based in certain log queries or specific metrics. And then after the alert has been created, you'll be able to see how many times the alert has been triggered. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about the logs that are available for us to use in our Traffic Manager profile. So let's go to our Traffic Manager profile and let's browse to logs. By the way, you will be only able to see the logs here if you have followed along with me and configured Diagnostic Settings for your Traffic Manager profile. Otherwise, you won't be able to see the logs here. So for the Traffic Manager logs, we have only one query that will help you to find the reason why the monitoring status of a specific endpoint is down. So it's going to help you to do further investigation. And again, because I don't have any endpoints configured to my Traffic Manager at the moment, we won't be able to see any information. Also, you might remember when we had been creating an alert, we had an option to choose from creating an alert rule based on a custom query that you might be able to put in Log Analytics workspace. So this will give you a lot of flexibility and freedom to specify your own query and create your alert rule based on what you want. That's all I have for you in this video. Now I'm gonna go back and delete my traffic manager profile because I'm not going to need it anymore. That's all I have for you for this video. Thanks for watching, and I'll see you in the next video. Hi everyone. This video is talking about how can we verify our traffic manager settings. And I'm going to put a link for this page in the description box. It's a really good read. It walks you through how you can use different Windows tools like NSLookup or IPconfig to check your traffic manager configurations. And also how you can test the failover, weighted routing method, and performance routing method for your traffic manager profile. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, I would like to share with you a really good document about some performance considerations for your traffic manager profile. In addition to some tools you could be using to measure DNS performance of your traffic manager. It's a really good read. I'm going to put a link for this page in the description box. Thanks for watching, and I'll see you in the next video. Hi everyone. Now we are coming to the end of this course, Azure Traffic Manager. And over 3 hours and a half we have talked about everything in Traffic Manager. I hope you've enjoyed this course and learned something new. Please let me know what you think about my course, and if you have any specific Azure service that you would like to be covered in future. Having said that, I have already other courses, so you can check them as well. And until next time, thanks so much for watching.